Good morning.
Morning.
Hi, Adrian.
Morning.
How are you?
I'm fine. Thank
Okay,
you.
I'm Camay Hunter.
Yes,
I
nice to meet you.
Nice meeting you too. I
Nice meeting
just
you, Miss
like
Hunter.
to pardon me.
Nice meeting you too, Miss Hunter.
Nice meeting you too. I'm trying to figure out your name. You are
I'm in Bermuda. My name is Orantis.
Orantos.
Yes, ma'am.
Okay. Welcome to our session.
Thank you.
Right. And nice meeting you. Did
meeting you
you
too.
get the emails that I sent?
Yes.
Okay. Were you able to print?
Yesterday? Or
I sent you some over the weekend. I sent some
Yes.
yesterday. Right.
These?
Right. Yes, definitely you would need that one.
Okay, and this one? Sorry, I don't know.
Right. Those two you would need for your assignment, for one of the
Yes.
assignments.
Okay.
Could you tell me just a little about yourself, your teaching experience, your experience with math?
I have a bachelor's in mathematics. My teaching experience is very, I would say, sort of limited. I've been working with special needs children. I've been a para for a little while in primary school. And a para means I deal with kids who have social, mental, or different type of issues. So I've been working with children in that, but I've also tutored a lot. So I tutored in mathematics. I said, let me just make the switch and then just go straight into teaching because I have a bachelor's in math.
In math?
Yes.
Okay.
I have other students on the, we have other students on the way. Not heard of just yet.
Pardon me?
There are other students on the way, but not heard of just as yet.
Right, so I'm giving them a bit of time.
Okay.
Hopefully they'll be there in another 5 minutes.
Yeah.
I'm hoping.
I think so. Yes. Yes.
Right. Yes, I hope so. Adrian,
Yes, miss.
are you still there?
Excuse me, miss.
I was just asking you to tell me a little about yourself.
Okay.
Yes.
Well, I teach at the secondary level, right?
What school is that?
St. James High School,
Okay.
right? I've been teaching there for 9 years.
How was the experience been?
It's very challenging. I'm still trying to find that formula to guarantee success, but while the passes are increasing, the percentage is very low.
Okay. But I hope whatever formula you find is one that allows for change because teaching and learning is a dynamic kind of situation that changes continuously.
Well, this course, the undertaking of this course has helped me a lot. So, I have a few plans to put in place for September. So hopefully, the next school year will be a better one.
Let's hope so. Over time, I'm sure the strategies that you introduce, especially I hope that you'll learn some this summer. As you said, you've already learned. I'm hoping there are more that you will learn that you can actually use inside a classroom that will work for you.
Right.
Okay? Yes. We're being joined by Karinka. Welcome.
Good morning.
We haven't officially started class as yet. Let's say good morning.
Morning.
So we're giving St. Lucia a few minutes. Hopefully they'll be here. Adrian, did you get my emails?
Yes, I did, miss.
Were you able to print?
Yeah, I printed some of the docs.
Okay. Alright, for those that you didn't get to print, it will be okay enough, I think, for you to use the computer. Hopefully you would have printed the one with the squares, the square grid.
Yes.
Okay. You have a few copies of that. They're recorded. And if it shares, that's all. No, I didn't. I should read it. Okay. I'm pretty certain you would have already looked at some of the guidelines in terms of how you operate in the conference and in the previous courses. Am I correct?
Yes.
Yes.
Okay, all right. So I'm not necessarily going to go through a list of rules, so to speak, but as one would expect, the cell phones, I'm sure you'll be turning them off just about now. And anything else that could be distracting? I'm going to ask that at the end of today's class, you find some time and check to see if you have Geometry Sketchpad on the computers at your center.
Say it again. What's the name of it?
Geometry's Sketchpad.
Okay.
It's a software that we will be using, but I just like to check if you all have access to it. If it's not on the computers in the lab, if you have a laptop with it, then I will tell you when to bring it, but I'd like to know by, say, Wednesday if you have access to it.
Sketchpad, right?
Did you ask a question?
Yeah, you said it's called Geometry Sketchpad.
Yes. If possible, if you've not used it before, you could probably go online to see if you can get a download to familiarize yourself with the basic tools.
Like one job for the money.
Welcome. Who is this joining us?
No heart.
Pardon me?
Heart.
Is this Rosina?
Yes.
Okay, welcome Rosina. Camay Hunter here. Thanks for joining us.
Thank you.
Camay Hunter.
And Crystal is on her way. Yes, I'll get Miss Hunter. Crystal is on her way.
Okay. I'm going to go through the assignments and hope that before we finish, we'll be here. Did you get a chance to download the emails?
Yes, I did.
Okay, thank you. Please remember to turn off your cell phone just before we start.
Doing that right now.
Thank you.
That's a second.
Circle on the square.
Yeah. Awesome. Look at it. See it. It is. You got it on.
I don't even know who's this.
I didn't even know. I do. She said 25. I said 55. Almost. I know.
It's outside. Are we recording?
Yeah.
Are you seeing the assignment clearly on the screen?
No. Yeah. Got a mini camera so you can record. Yeah. Yep. You see it.
Thank you.
Oh, just a repeat.
Adrian, are you still with us?
Yes, I'm here.
Okay. Are you seeing the assignment?
No.
Did you print a copy?
Yeah, I print a copy so I can follow from my copy. I think the projector is not on.
Oh, could you turn it on?
Here's the Japanese.
All right, let us discuss the assignments first. And then by the time the others get here, then we'll begin our discussion for today. Did anybody get to read the article, Folding the Corners of the Habits of Mind?
It was closing the habits. I thought it was a something about someone.
Oh, I should have read that.
Rosina?
I'm looking, I actually read what's happening to geometry on a sphere.
No, those two would have come together and would be part of the assignment, one of the assignments you'll be doing. Don't worry, we'll talk about it and you can read it later.
Okay.
But what is it?
I think it came one. It was the actual link, right, Miss?
Yes, it was a link because I wasn't able to email you the PDF file.
Right, it's
It
like 300 something pages or something.
It is protected. So what I did was to send you the link to NCTM so you could actually go there and link and read it as a guest. Don't worry, you can do that later today.
Okay.
Okay, so let us look at the assignments. We have 3 assignments essentially. Because of how short the semester is, you're going to be under a lot of pressure to do the 3 assignments in a short space of time. Now, what we can do is look at the dates that we have and see how best they suit you, because I do know that it is going to require some amount of work. So for assignment 1, I've set the due date as August 4, and that assignment requires you to do some amount of problem-solving work and then to examine patterns and generalizations for that assignment. Now, that assignment is 30% of your course grade. I suppose you would have read it already. Is there any question about that part of the assignment?
Will we learn how to do all of this when in the class?
You will have enough help.
Okay.
Yes. Yes.
I have a question on the town hall tile.
It's about?
The town hall tiles, the first
Yes.
question.
Yes.
Are we including the blue lines in this question or no?
Are you going to be doing it?
No, including the blue lines, like you see how you have black and white tiles?
Right.
And then outside the tiles that are colored, they are blue or dotted lines.
Okay, the blue lines, the blue dotted lines are not a part of the pattern.
Okay,
The pattern, okay, that answers the question?
yeah,
Yes, very good question. I figured it would come up. So we're focusing just on the kind of diamond shaped,
right,
yes, the rhombus
All right.
part of it with the colored tiles and the white tiles inside those.
side, okay.
Okay. Now, when you look at those town hall tiles, look across now at the pyramid that's
Right.
next to it. The pyramid has been formed with a different kind of base than the town hall tiles. But it is just to give you a picture of what we will expect for the third part of it, which is a flagpole that you will construct. Not physically, but of course, I want you to get a visual picture of what it is that you will be expected to do. Now, the final text box says, consider the patterns used in the town hall tiles and the pyramid above. So you're going to be constructing a pyramid for the flagpole that has a base that looks like the town hall tiles. Right? So if you were to actually get square tiles or cubes, I do have those here, unfortunately, for those of you who are not here. You'll be able to take out and form the pattern. So if you can get your hands on some square tiles, you could actually use 2 colors or the cubes to do it. You're going to be exploring the patterns involved. Now, if we were to use cubes where you have the black tiles and leave spaces between them, then you can see how the pattern is formed. When you begin experimenting, it will become more visible to you. Now, there are other widths that you can use. So for example, this one is 7 across. So if you start counting from your extreme left in the middle, the first black tile, then there's a white tile, and it continues straight across, and you'll have 7 tiles.
Right.
From top to bottom in the center as well, you have 7 tiles.
Miss Hunter, just a question.
Yes.
Are you showing a demonstration with the blocks you have now, or you just
I'm just referring to them just in case you wish to use them.
okay. All right.
Right. Once you begin using the tiles, you can use either square tiles or the blocks, whichever one will help you to get a visual picture. If you're using square tiles, I'd suggest you use 2 different colors to make the pattern visible. Believe you me, once you start working with it, you'll figure it out. Now, I'm gonna suggest too that you examine different widths. So for example, we'll consider this one a 7 by 7, count across the middle, and count down the middle. So across and vertically we have 7 tiles.
Right.
The tiles are alternated. So you'll have a black, then a white, black, then a white, and so on. Now, you will also be able to form other patterns that look very similar to this one, of different widths, of course. And I want you to write down the different observations that you have. Once you start working, and I'm going to find a way to group us today, I'll try to work with what works best for you. So if it is by campus or whichever arrangement you have been using that you found to work. If you have questions, yes, go ahead. Go ahead. Is that a question?
For me,
Yes.
just wondering, should we work as a group as where we are, like Bermuda, St. Lucia, West Campus, and Bueno?
Okay. The assignment will allow you to be able to work across campus once you have internet access. So the assignments that are group work, you won't have much of a problem linking with the persons. And because St. Lucia has only one person, it may be difficult for them to do the assignment by themselves.
Okay.
Western Jamaica as well.
Yes, Western Jamaica as well. I'm sorry. My apologies. I did remember that there was somebody else who was alone. Assignment 1 though is individual, and by the time we get into today's class and Wednesday's class, you'll begin to feel more comfortable working with assignment 1. So by the end of this week, I believe that the weekend you will do it and you'll be well on your way to completing for August 2 or 4.
4.
Right. It will take some experimentation. Now, that assignment requires you to do another section. Let me scroll down so you can see. So you'll be sharing your ideas on the nature of mathematics with your principal, somebody you work closely with, maybe your head of department, you're trying to convince them about something. So it says the course has provided you with insight about the kind of work that students need to be engaged in to be learning mathematics in a meaningful way. Now you'll be doing some practice in here, you'll be solving different problems. And by the end of the course, you will have had some experience doing some meaningful mathematical tasks. Tasks that are not of a routine type, but they will allow you to also include the content that you would cover through routine methods. And you'll have to write a proposal just to encourage or to convince your principal that it is important to do work of this nature. Now, for that assignment, it is suggested that you refer to whether your own experience, what is it that has worked or not worked in that experience, and also whatever work you would have been doing in the class and also on assignment 1 by that time. Right? Part A of assignment 1, that is. The other 2 assignments are group or pair assignments, and you'll be selecting a piece of technology. I have made suggestions, the graphing calculator or some computer program that of your choice, or some kind of application from the internet that students can actually use to help them better understand mathematics. Basically, your presentation will require you to just generally talk about the usefulness of the tool that you have selected and some of the limitations of the tool, because we know even though a piece of technology might be very good, there are limitations when it comes to teaching a particular subject, and in this case, mathematics. So we're going to try to look at that. And we're going to try to figure out, even if you're not doing all of these topics, what topics can you use this piece of technology to help you with? For example, Geometer Sketchpad, that we will use at some point early next week, can help you to look at a number of geometric ideas and explore them in a shorter time than you would if you were to use graphs, pencil and paper, and experimentation that does not use that particular technology, right? And so you will do that, and then you will actually use the tool that you have selected to teach a concept that you have selected for the secondary level now. Is that a sign? Or did you just decide which topic you're going to teach?
July 3rd.
Oh, because now you'll notice that the due dates are July 30 and August 11. You will be taking us through the use of the piece of technology that you have selected. And so 2 groups are scheduled to present on the 30th of July. 1 group for the 11th of August.
How many is in a group?
Is that a question?
How many is in a group?
How many?
Yes.
It's in a group, yeah.
We should have 11 or 10 students. I'm not 100% sure. I guess by the end of this week we'll know exactly how many persons are participating. How many persons were in the first session? 8 persons?
I thought St. Lucia had 2 people.
Yeah, this is it. So Lucia had 2.
This is any man?
And Lucia had 2. Western campus had 3.
1.
Picking for
No,
those campus
the last
clusters.
class, Adrian. How many you had the last class?
You had 3.
You had 3 last class, right, Adrian?
3 at Mona. One of the persons from Mona will not be able to attend, but I think she will be doing the assignments just the same. She will be viewing the recordings. And so what I'm going to ask is that those persons who are on Adrian and who is in St. Lucia? Crescentiana. Those 2 persons will join a larger group for the assignments.
Okay.
We'll have to do it. Right, so they wouldn't have to do it on their own. Welcome and good morning.
Good morning.
How are you?
I'm late, but I'm sorry. How are you?
I'm fine, thanks. We started looking at the assignments. We're still on assignment. No, just moved to assignment 2. And
Okay.
later on today, we'll decide how best to group you. Now, if it becomes necessary, then we may use 2 instead of 3 groups,
Okay.
right? If the expected numbers turn out, then we'll use 3, but depending on the numbers. If we have 8 or 9 persons, we could do 3 groups. Less than that, then we'll work with 2 groups.
And then we would just then everyone would just complete on the 30th, miss.
Yes, complete meaning the presentations.
So I'm not going to be doing that.
By Adrian, was that you?
Yes, ma'am.
Right, so I'm saying when you say complete, do you mean complete the presentations or the course?
The presentation.
Yes, then we would do that.
No, I have a request. I'm actually not present on the 30th, so I want to know if we can do the 11th.
Pardon me, we didn't hear you.
I will not be present on the 30th.
Be here on the 30th of July.
Yes.
Okay. And would that mean that you would it mean that you would be out for the entire day, or you could opt for the morning or afternoon?
I will be out the entire day.
Be out all day? Okay. So we could discuss with your group mates, because we will have a class on the 11th of August. Now, the 6th of August is holiday in Jamaica, and I think that is going to affect our class that would normally be scheduled for the 6th.
And we're on vacation on the 31st, but we'll have to get the, yeah, but we still busy here.
The 31st of...
The meeting's on the 31st, yes, of July.
Okay, well, that wouldn't affect this particular class. So our schedule though, our schedule would be Mondays and Wednesdays.
Oh, yes, okay, yeah.
We start at 8:30. Right, so it wouldn't affect our class. So July 21, 23, 28, and the 30th, and then August 11th. The big gap is because of the holidays that that fall between those 2 dates. Okay? If you are having any difficulties at any point in time, feel free to call me, send me a message, email me, however you can communicate. I will give you my phone number by the end of today's class. So let's move on to assignment 3. Now, the 2 articles I sent you, you can read them in your own time, but you will have some reading and reflecting to do on those 2 articles. Now, there are 3 parts, A, B, and C. Parts A and B you will do as partners or in your groups. And part C, you will write a reflection of no more than 400 words, around about 350, 400. Reflecting on the experiences you've had working with the article. There are some questions and activities that you will do from the articles. And so you're going to do the write-up of whatever it requires you to do for A and B. Everything is outlined there. As I've said before, feel free to ask any question as you go along. All right, so once you get into doing the assignment, you may find that there is some question that you need to ask. Feel free. Save your assignment. I'm going to ask you, please, if nothing else is done, please ensure that you save it with your name and your assignment number. All right, it makes it easier to know who sent in which document. Or name or ID number, whichever you choose to use. Okay. Crystal?
Yeah.
Did I get your name correctly?
I'm sorry. Yes, you got my name correct.
Okay. I wanted to find out, did you get any of my emails?
I did actually.
Okay, just want to make sure that all the email addresses are working and so that we can communicate easily.
Yeah, you sent me 2 emails, right?
About 3 maybe.
3? Oh,
Yes. If you got 2, you should get the 3rd one.
Okay. Sorry.
Don't worry about that. Okay, so we should be good where assignments are concerned.
That first one you got to be two.
Our discussion this morning will focus on a few ideas. The overarching theme is mathematical thinking, and all of what we do hopefully will help us to help our students develop mathematical thinking, if it is possible to do so. Right? You will see habits of mind and cognitive demands. Those are two of the areas we will look at. We'll touch a little on problem solving, but then we will focus next class a bit more on problem solving. For today's schedule, we expect to run until 10:30. I'll give you a break, a 15 minutes break. You can use that time to do whatever you wish to do in that time. And then we'll come back at 10:45 and go for 1 hour. So we'll do 3 hours in the morning, basically. You'll have lunch, and then the next 2 hours in the afternoon, we'll come back and resume class.
Miss Hunter, you know we're 2 hours ahead, right?
Yes, you are, I suppose. What time is it now?
11:30?
It's 11:30 for you?
Yep.
Okay, so at 12:30 your time,
Okay.
15 minutes. And thanks for that.
No problem.
Right, thanks for making that clear. I note that, I wrote it down. How about St. Lucia? Same time? Okay. Okay. The time would be 1:45. Is that too late?
No,
That's fine.
that's fine.
And so is an hour good for lunch?
Yes.
We come back and we start at 12:45 our time, 2:45 your time. And we'll continue until 2:30 our time, 4:30 your time. And class will end at that point. Okay? Right, so that's basically how I will try to schedule the classes. It depends on the kinds of activities we're doing, but we'll try to do 3 hours in the morning, 1 hour for lunch, and then 2 hours after lunch. Now, so let's look back at mathematical thinking. When you hear mathematical thinking, what comes to your mind? What are some of the things that you expect to see if persons are thinking mathematically?
Numbers.
You expect to see numbers. Okay, fair enough. Patterns. So we can skip this class then. That's good. That's good. Now, since you say people should be thinking, let's start off with something wrong. If you have an analog clock, can you tell the time when the hands of the clock will be exactly at right angles to each other?
Yes.
How about another time? 9 o'clock. Have you done this question before, by the way?
No.
So you can see the 90 degrees, right?
Yeah.
Okay. How about another time?
9:30.
3:30.
9:30.
Okay, so get your pencils out, sketch a clock, use up some of the diagrams that you just mentioned, and let's see when again the hands of the clock will be at 90 degrees. Adrian?
Yes, miss.
Okay.
Oh, that's not the difference. No. No. 9 to 9:30.
Are you able to read the screen?
No, miss.
Are you able to read the screen in Bermuda?
Yes.
Okay. That better?
Yeah, that's better.
Okay, thank you. And if you are having any difficulty, just tell me so we can fix it, please.
Yeah.
Adrian?
Yes, miss.
Okay, what time is it in Montego Bay, by the way?
I would love to say that we are 2 hours ahead, miss.
Okay, okay. I thought you'd say 2 hours behind. Anybody with any other time they think you'll be at 90 degrees?
I don't know.
3 o'clock, 3:30, 9 o'clock, 9:30.
3:30, somebody said 3:30?
Yeah.
Exactly 3:30? What happens to the hand of the clock when it's half past?
It's between, halfway between. So maybe about 3:30.
So we're saying a little more or a little less than 3:30? Is that what you're saying? Or does it have to be a little more or a little less? Which is it?
3:20.
A little earlier or later? A
Earlier.
little later than 3:30?
Earlier.
Earlier?
That's to be about 3:25 or 3, yeah.
What about 119?
You want to set your clock? Do you have an analog watch?
Oh yeah, I do.
Ah, you think you could experiment a bit with that?
Sure, why not?
Why not? Anybody else with an analog?
Yes, miss.
I wanted to reset the time. Somebody can't bother to reset the time. Could you please take off your watch and try? Would you like to try with mine?
This one here.
You have? Okay. Some of you have phones that you can use an analog. Now, is this an activity that you see yourself using? You think you could use in a classroom with your students?
11:45.
Yes, miss.
11:45 is one.
What time was that?
11. Don't give me a right angle.
You said 9:45? I'm lip reading now. 8:45?
45.
11:35?
15 minutes before 12.
15 minutes to 12. 11:45. Exactly?
Yes.
I hear 11:10. Tell me if you agree or if you don't agree.
Yes, I agree.
Don't agree.
We have to figure out exactly what time. Notice the question says, at what time will they be exactly at 90 degrees? So I suspect you have to have an exact time. Fair enough? Fair enough. Anybody lost?
Yeah.
Is anyone lost? Your hand was up. Go ahead.
No, it's just.
No, not gonna be like, it's gonna be like 11, between 10 and 15.
You said somewhere between?
This one?
That
Somewhere
was
between
more-
what times?
That was. It's because the 11 is, the hour here keeps moving every time you change that number.
I would say 11.
Miss, 11:10 is 90 degrees, you know.
That answer sounds sure. Okay. Let's give me another one that sounds just as sure.
Yeah, just right.
Does everybody agree that 11:10 is 90 degrees?
The other one, exactly.
It looks 90. Okay.
But you can't that green, right?
Oh, I
See
see
what I
that.
mean? But It looks like they all need to be.
Now, let me ask you very quickly. What kinds of mathematics do you see students getting from just this activity, which is not a mathematical activity, is it? It doesn't have to be something you could ask outside of a mathematics classroom, right? It has a lot of mathematics, but what kind of mathematics specifically?
Geometry.
Okay, so there's geometry going on in there. What part of geometry?
Angles.
Angles. And so a prerequisite for this is that students must have an idea what a right angle is. They must also know what else? How to tell time.
Time, yeah.
Right, so that's some kind of measurement. What kinds of mental activity do you see happening here?
Estimation, miss.
Some people were guessing. How did you make your guess? Did you just say a time, 1 o'clock, 2 o'clock? What informed your guess? You were trying out different things, right? Did you have to think about this?
Yeah.
A little bit.
More than you normally would? Okay.
Yes.
I agree. Now, I'm hoping that you will find a class that you are teaching that you can actually use this or some variation of this question in that class. I want you to just quickly look at some solutions. Now, of course, you did give the very popular 3 o'clock, 9 o'clock, which comes very quickly to mind. Now, I don't have to read these for you. Can you see? Plus, you also gave us some additional ones. 11:10. I will have to check to make sure 11:10 is correct. Can somebody set the clock? You did. And it looks a little bigger than 90. If that's 11:10, you sure that's not 10:10?
I think it's 10.
So 3 is from 8:30 to 9.
To notice. Were you saying something?
I meant to say 11:45.
Yeah, 11:45. Yeah.
Okay.
Good morning, everyone.
Good morning.
Morning.
Just switched.
You said. It's complete.
Right. Just to say good morning and to welcome everyone to the start of the second round of summer school. Just in case you don't remember who I am, I'm Chantal Moore. I coordinate the program. I am the person behind the scenes trying to get things organized as best as we can. So I'm just checking in to make sure that everyone is here this morning and things are going well. A special welcome to Ms. Hunter, who will be working with you this second semester in the summer. And you'll be introduced to your other lecturer who, you already know her?
Yes.
All right, Avaloy, right, McCarthy. So she'll be the other person teaching you your math courses this summer. I'm going to be sending you correspondence soon regarding, the process going forward. But I'm pleased to report that we are more or less almost there in terms of registration, in terms of getting things sorted out. And it's been a long process. Don't think that we're not trying to get it, but when you have to deal with different arms of an institution, there are protocol issues which take some time. And so I think that we have rectified those to a great extent. And even for the Jamaican students, I have good news with regard to the Ministry of Education. So that I will communicate to you privately, right? I don't think that others need to know your business. But welcome Bermuda, and
Hello.
welcome Western Jamaica campus. And we should have one student from St. Lucia. Not sure what's happening, but we'll follow. All right, so all the very best for summer. And you're almost finished with your taught courses. Can you believe? Almost there. All right, almost there. And we have already met and made plans your study and your practicum. So those kinds of information will be conveyed to you towards the end of summer school. All right, so thanks a lot. All the very best for a great day.
Have a great day.
Thank you, miss.
You're welcome.
you.
Bye, guys. Bye-bye.
Adrian, can you see the screen? Let me know, please.
Little bit to the right.
Bermuda, are you seeing the screen again?
Adrian, more than we see.
Adrian, are you seeing it now?
Could you go up? No, miss, I'm not seeing the left margin.
Okay. So Adrian is not seeing the left margin. Alright, so we'll adjust the screen so you can see the left margin. Adrian is not seeing the left margin. You adjust it. You probably zoom out or in. Right. Adrian, is that better?
No. No, miss.
Okay. Is it any better?
Yes, miss, that's better.
Okay. Bermuda, are you seeing the screen?
Yes, yes, we are.
Okay. Alright, so a few of the objectives, because we really can't even identify every single objective that we will be trying to meet. But we want to examine some of the processes involved in mathematical thinking. We want to identify and explore some critical habits of mind. And as you read two particular articles, the one for this morning where I sent you the link, and also another one I will send you from E. Paul Goldenberg, Habits of Mind as an Organizer for the curriculum, but that you will have to take some more time to read. It is about 22 pages of good reading, and so you'll need, it is interesting though. It's a lengthy article, but very interesting. Now, we'll also want to engage in some amount of problem solving. You started that already, and we'll continue that throughout the day. I want us to be able to, as we go.
We're going to the board. Is that Christian Dio? Is that?
Vice President.
What's his name? I don't, just the first one, so I tried to find distinction between the novels of cognitive and language.
Hello.
I think you can hang up, because she's probably coming between languages and two different levels, and distinct between levels and cognitive.
Adrian, we gotta hang up or what?
I think we have to dial again.
Alright.
Oh boy.
Is it your copy or your copy?
Oh, mine.
No color. On black and white already. Well, I didn't realize. It was a color.
You guys got the email from Dr. Aha?
Yes, it's just been in my mouth today.
I can't bring my colors. I ain't got my buttons on.
I had a blue and white shirt. And I got, after the baby. But I have Brazilian boobs shirt.
Okay, cool.
Are we back online?
Except Western Campus.
Bermuda? Western Campus?
Not there yet.
Not there as yet.
We usually have to do that for they usually have come first.
Could you repeat that, please?
Chris, we usually have to check in live, Bermuda, and then, if anyone else comes in, we have to come in after. In order for us to actually, everybody to be up at the same time.
So Western Campus would have to call first and then you would have to call back?
Yeah, so maybe we should hang up again.
I'll wait until both of you are reconnected to
Okay.
continue.
Okay, so we'll
We'll
hang
hang
up.
up. Yeah. Yeah.
Session? Not this summer? Okay. How do you like it? Completely this clear? Well, it was an English student.
Yeah, of course. Combination.
Maybe it's something in your hearing, so in general methods.
So I think when I think about it, it's out there short difference between the straight line normally in any classes just travel half like this. And then so that as a leader we look for assignment class and the
Oh.
algebra patterns.
Sure, the difference between.
But the thing about it is that the algebra patterns and just put them on that.
Because the meaning is less, you see.
Hello?
You're back? Welcome back.
Yes, I'm back.
Alright, we've been waiting for you, so don't worry, you haven't missed anything.
Alright, thank you.
Right. The next campus, they had joined us, but they're gonna have to join us again now that you are back.
Okay, Bermuda's back.
Bermuda is back?
Yep,
Okay, thank you, so we can resume.
yep.
Yes.
Other things I want to look at, want to identify and describe some of the thinking skills used in problem solving, and you'll find that mathematical thinking involves these same skills, right? Now, to identify, we're going to be trying to identify and distinguish between levels of cognitive demand, and we'll talk about what we mean by cognitive demand. And then we'll classify some problems or tasks just to see, what we mean by cognitive demand and see what kinds of cognitive demand these particular tasks are placing on a student. What is mathematics? You've answered that question maybe a million times. To yourself? Not the board. Right. What is mathematics? As we talk about the nature of mathematics, we need to try to at least have some answer, and I want you to give your own idea of what is mathematics. We've been teaching it. It doesn't have to be an official definition, but what do we think mathematics is, and how do we come to know mathematics? Now, our ideas of how we come to know mathematics will definitely influence how we teach it. And so let's talk a little about how we come to know mathematics and how do mathematicians work. Are we mathematicians? Do we work in the same way that mathematicians do? Do our students get the opportunity to do some work like mathematicians do? All right, so I'm not sure who wants to volunteer, but let's talk. What is mathematics?
Mathematics is, I would say, the use of numbers, computation.
We definitely are using numbers and we're computing all the time. What else are we doing when we do mathematics?
Using concepts.
Generalization.
Alright. Talk so you can hear everything.
Mathematics is all about finding generalizations and rules.
Okay.
Find patterns.
Okay, so we're looking at the patterns. We try to establish some kind of rule and then come to some kind of generalization about the set of patterns that we see. Alright?
Using concepts.
Learning and using concepts, you said?
Yes.
Yes.
I don't know if this is right, but I think it comes in for preset solutions, meaning that the answers, we always have, like the answers, you can always arrive at the same answer.
You said something about 3 steps or?
No, I was saying that it's like we always have preset solutions, meaning the answers are always going to be the same, no matter how you get to it.
Okay, so using various solutions to come to the same place? Same
Right.
solution.
Yeah.
Right, so solution strategies, we're encouraged to use different solution strategies, and in mathematics, it certainly should be one of the things that we encourage for ourselves or practice for ourselves and encourage for our students. What do we see though happening very often in a mathematics classroom in terms of methods and what students are expected to do? We see that happening. Do we see students using a variety of solution strategies and the teachers being accepting, of these strategies and saying, very good, commending the students for using various strategies? Or do we want
No.
them to follow? Okay.
Generally, we ask them to follow it.
Okay, we ask them to follow us because we are leading. Yes?
Generally, like, leaders more emphasize and sit there.
Emphasize quickest or most efficient routes. Now, who determines what is quickest or most efficient? Is everything okay? Adrian?
I'm here, miss. There's a bit of cleaning going on.
Could you step outside and ask them to stop, please?
Okay, miss.
Right. Now, as we accept and try to encourage students to use different solution strategies, we will definitely be encouraging them to lean on their own way of thinking. We'll wait for Adrian to join us because the sound is disruptive. Thank you, Adrian. Can you mute your mic a bit? Is everything okay now?
Yes, miss.
Okay, thank you very much. Right, so we were saying who determines what is most efficient for a student? Now,
The student determines that. Right?
I do believe so. Now, if students work,
It's not,
go ahead.
I'm saying, you're saying who determines it? Wouldn't you assume that the student determines it?
I don't know, I'm asking. And it's not necessarily that you have to respond to that particular question, but let's think about it this way. If we work with our own preferred ways of working, where we're more comfortable, then we end up thinking about the things in probably different ways because of our different experiences. And so students will have inclinations to work in different ways. So some persons may need diagrams to help. Some persons may need actual objects to work with. Some persons can visualize and sketch whatever they need and do not necessarily, some persons don't need the diagram at all. Everything is done mentally and then they present a solution that is different from probably other students in the class who have done 5 different things. So we need to be aware as teachers that students come with different ideas, different experiences that will support the mathematics that they're doing. Right? And so there are different places, I would say. If you're coming from Montego Bay, if you're coming from Bermuda, or well, St. Lucia is not here today, your route is going to be different. So I couldn't give you the same directions from Bermuda to get to where I am. I'd have to give you a different set of directions. Does that analogy work?
Yeah.
Yes, miss.
Right. So it's kind of like coming from different places, having understanding, and then using that to construct your understanding. Now, how do we learn mathematics? How do we, were we born knowing all of this mathematics? Are we gonna just come into the world and figure it out ourselves? How do we come to know mathematics? What kind of exposure do we need to learn mathematics? What do you do in the classroom to help your students to know mathematics, to learn mathematics?
Introduce them to the concept.
Okay, so first there's some kind of introduction. Before they come to you, what happens? How do they learn about mathematics? Because you're at the secondary level, what happens before that?
Experience or experience?
Alright, cool. I just don't want to go in.
By experience, you mean
By attending previous class and by life experiences.
talking both about life experiences
Life
and also
experiences
and
also-
formal mathematics.
Yeah.
Right. So formal mathematics teaching and what you learn as you go along, maybe at home, in the community, and so on. Now, much of this mathematics that students know before they come to formal schooling may not be taught as mathematics. It's just part of their way of life, part of how people operate on a day-to-day basis. They learn how to follow certain steps to use a banking machine. And we talk, when they come to mathematics, we expect them to follow instructions, follow certain algorithms, which you spoke about in last session. You looked at algorithms in last session, right? I'm trying not to do overlaps with the last session, right? Now, if students are working like that, are they really experiencing mathematics? Think about what you did as students of mathematics. You don't have to confess, but think about what you do as teachers in the mathematics classroom. Are the students really experiencing authentic mathematics learning? What kinds of activities are they doing, and what kinds of activities do you think they should be doing? Are they the same as what you're now doing, or do you think there needs to be some kind of change?
It should be a build up on that.
Remember we're sharing with everybody. Yes?
I was saying yes, there is room for change.
So there's room for change. And that's Orinthia? No, sorry. Rosina, sorry.
I was saying, remember, it's a build up. You're building on experience to try to go on what their prior knowledge.
If your experience is like ours here, very often we hear that these students can't think. What were they teaching them before?
Yeah.
Does that sound familiar?
Yes, very much so.
Okay. What do you mean when you say they're not thinking? Don't we all think?
Yes.
They're not thinking for themselves. They're just trying to think. They're trying to think what you want them to think.
Okay, so they're kind of religiously following the steps of the previous teachers, maybe?
Yes.
Do you think,
knowledge-based versus conceptual learning.
can you think of a young child, maybe a 4, 5, or a 6-year-old, who you've who you've interacted with at some point, and some of the questions that they ask? Now, they would not have done much formal schooling before that time, and are still at the stage where they're asking questions. They're curious, excited to learn things, and everything you ask, they ask you what? Why?
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 When?
What happens when you get stuck? You're not sure what to tell them. Our students at the secondary level to begin to ask those questions.
What's the question again?
Just want them to be curious again about learning. We just want them to be.
Okay.
sometimes they ask you a question and you wonder where they get that question at all. How did it come into their mind?
So we can ask them why.
We should start asking them why.
Yeah.
Well,
Okay.
I
So
would
to find out what their logical thinking is.
I've come across students who say, why do I need certain subjects? Like, why do I need science? Why do I need chemistry? Why do I need math? Why do I need English? I think as a teacher, you may have to show them where math and all the other subjects are involved in real life situations. Like mathematics, if the individual wants to be a carpenter, he has to learn how to measure. Or engineering, he has to learn how to calculate the engineering stuff in the mathematical terminology. So I guess if you show, as a teacher, if you show where math or science or wherever the subject matter is, where it matters in real life, then they'll probably become a bit more interested. I'm not sure.
Okay. I take that point, very interesting point, because as teachers we try to make mathematics real for our students by introducing contexts and situations that would work. Now, let me pull your legs a bit. If you were teaching a class of, say, 25 students, and only one wanted to be an engineer, and the content you're teaching is going to be interesting for that one student only, what happens to the other students? Likewise, if only one wanted to be a doctor or a nurse or an architect, what benefit would the others have from learning that bit of mathematics? Because I would just turn off if I hear, I'm not going to be an engineer, and this is for the engineer.
Yeah, you would lose your interest.
Yeah, you lose your interest. I think you gotta make it interesting for all.
So asking them why, if they gave a solution to a question, and then asking them why, so that they can put it in the context of what they're interested in.
And since it's difficult to find everything that works, fair enough. You were saying?
Oh, that's something might be hard as an individual student. You have to, if an individual is an artist, something you can show him.
Okay.
But I guess maybe if the other students are not interested, they just have to go on.
Okay. So every student in front of you, I think, wants to know, why do I need to attend this class, apart from the fact that the law says I must be in school? As a teacher, you're teaching a subject that many people do not want to learn. But there are things about mathematics that are not content specific that you can sell in such a way that mathematics becomes interesting to the user or to the student. That's kind of where we want to focus. Is there a way of organizing our teaching and the curriculum that students can become engaged in certain, what we will find out later, we call habits of mind, certain ways of thinking that will help them to want to learn the mathematics simply because of other reasons than the fact that it is important in this particular area. But they will learn habits of mind that are important right across whichever subject area they're studying and also in their daily lives. All right? So that's kind of where we want to go today. Now, think about the mathematicians you've heard of. Do you know of any stories of mathematicians? Probably extreme meaning spending years in a room locked up trying to solve a problem, trying to figure out something, or years working on the same problem. Scientists or mathematicians you can think of? Isaac Newton.
Einstein.
Teacher the son?
Wells?
No.
I'm sure you've heard some stories of mathematicians who've had to work long and hard. When you were doing mathematics content, did everybody here do math content as part of their first degree? Yes, content.
Yes.
No, it's not the name of the course, but some kind of content, higher level math content.
Yes.
Yes, you would have. Right. Now, can you think of that concept that you had to spend 2-3 days, maybe a week going over before you really were able to probably understand it or probably be able to remember it enough to probably do a question like it?
Yes.
Now, how many of your students are willing to work on a problem for days? Is there that desire to do it?
No, not.
No, miss.
Might have
Okay.
one or two.
So the right.
Do we think we can excite our students in such a way? And this is when you know you're a good math teacher. When you get your students, even when you didn't give them homework, to leave the classroom thinking about what you just taught, thinking about how they're going to find a different solution, how they're going to make a better solution than you even presented in class, and come back and talk to and share it with you or the other students what they figured out on their own. All right? That's the kind of math teachers we want to be, and I'm sure we'll all get there at some point. You have some students like that. We want you to have most, if not all, your students doing mathematics in that way. Alright, so school mathematics should have students really thinking about mathematics even outside of the classroom, how it can apply other places. Now, mathematical thinking is independent of the content area in which it is used. We'll talk about that. We started talking about it already. It doesn't matter if you're doing geometry, algebra, or whichever area of math. The kind of thinking that you employ, the way you go about using your thinking skills, should not be dependent on the content that you're using. If you're the kind of person that will explore, try different things, it should work for different areas. Some skills may be more adaptable to some areas, but generally speaking, mathematical thinking skills are used across a wide cross-section regardless of the content. Now, mathematical thinking takes into consideration processes through which mathematics is learned. And we spoke about some students having a fear earlier. It's not only a cognitive domain, we have to think about the affective side of mathematics. How does it make you feel when you've worked on a problem for days and you still cannot get a solution? How do your students feel when you've taught the topic twice, you reteach, you teach, and they still do not understand? That feeling of failure that overcomes our students, or that feeling of excitement when I did it, I solved it, and nobody showed me how to, I did it on my own. Are they empowered to feel that in a mathematics class? Welcome.
Yes.
This is Donna. So, yes, we're being recorded. So we're going to look at something more about mathematical thinking and the processes involved. Now, Leon Burton, in the Journal of Research in Mathematics Education, says mathematical thinking is not thinking about the subject matter of mathematics. So it's not about the content so much, but about a style of thinking that is a function of the particular operations, processes, and dynamics recognizably mathematical. So it's not so much that you have students engaged in doing this bit of math or that bit of math, but the way in which you have them access and think about and do the mathematics. A question I ask my students all the time, student teachers or in-service teachers: where does the mathematics happen? Does it happen on paper? Does it happen in your head? Where does the mathematics happen? For individuals, yes. So the useful part of the mathematics is about how we think about it, how we process it. Are you still with me? I'm going to send you the PowerPoint this afternoon. Okay?
Okay.
Okay.
Right, so Right. So I'll try to, every time I do the PowerPoint, I'll send it to you so you can have them, and feel free to use them. All right? As a community, once one person works, the rest of the team can share the work, right?
Right.
Agree.
As I've read, but I'll try to introduce you to articles that will help you to do your own reading about the areas at your own leisure. So that's Leon Burton on mathematical thinking. We'll talk some more about habits of mind and mathematical thinking further on. Now, some of the processes involved in mathematical thinking: convincing, let's start with specializing, conjecturing, generalizing, convincing. Now, are you familiar with these terms? No, I'm not asking you to be certain of an answer, but are you familiar with these? We will look more closely of what they mean in mathematics.
Generalizing
Okay.
and conjecture.
All right, so we spoke about generalizing earlier this morning. We're going to look more closely at these processes. All right, so let's try to understand what the processes mean. When we talk about specializing, let's say, for example, the assignment one that you will be doing on your own. When you look at the problem with which is a 7x7 town hall tiling, you're like, what is this asking me to do? But by the time you try to figure out a general solution, you'll realize that one situation will not allow you to figure that generalization out. Right? Is it possible for you to zoom in on the desk? On what? Right here. Is it possible? I'm not sure, but okay, could you go more to the right? Down. Okay, thank you. Perfect. If you can make it just a little bit bigger, I'd be happy. Zoom in. Can you see that pattern?
Yes.
Yeah.
While we lost connection, I just decided to make the same pattern but using a different width. Now that's a special case. Can you see that?
Yeah.
Western
Yes.
Jamaica?
Yes, miss.
Okay. Now, can somebody tell me what's the width of that pattern?
4 by 4.
5 by 5.
1, 2.
Five.
Yeah, sorry. 5 by 5.
5 by 5. Now I'm gonna ask Donald to just remove all the yellow tiles on the outer circle, I will call it. All of them. Do you see a pattern remaining?
Yes.
What's
Yes.
what's the width of that pattern?
3 by 3.
Alright, so it's a 3 by 3 pattern. Now, do you see where I'm going in terms of looking at special cases? So the width you got to work with was a 7 by 7.
Yes.
In working, I would expect that since you can't make a generalization by using simply one, you would probably look at other widths that are possible. Now, if you can do the 4 by 4 or the 2 by 2, whichever, if you can do them, then you would try to do them and then try to see if there is some kind of rule that governs the patterns in all of these different cases. So specializing, when it says try special cases related to a problem in an effort to understand the problem. Expose and test patterns or proofs. And so you're expected to be doing some of that as you work on number 1, assignment 1. It may also be described as investigating particular cases in an organized way in order to move on to a generalization. Right. All right, so can we zoom in on the screen, please? Thank you. We're gonna talk about, is that sufficient for you in terms of specialization? Is that clear?
Yes, miss.
Okay, so you look at special cases and it helps you to move towards making some rules, generalizations about. Now, conjecturing. As you read the article that I sent you the link for, you'll also get a sense of what it means to conjecture. Alright? You make a decision about what you think is going to happen, and so you kind of make a guess about how you think it's going to work or why it works and so on. And then you check to see if that's working. This is a process of making a shrewd or informed guess as it relates to a mathematical problem or situation. Now, conjecturing may occur after some amount of specializing, where a pattern is articulated and then tested further by specializing again. So for example, if you start working on the problem, you say this is gonna happen, or this happens when X happens. So you make a conjecture, and then you go back and you do some more special cases, or special cases of a different kind, to test if your conjecture makes sense or if it is true. The process of generalizing, this is a process of moving from a few instances, which is what you did when you specialized, to making guesses about a wider class of cases. So maybe you were working on your patterns and you recognize something about odd numbers, even numbers, or first level, second level, third level. Do you have a question? Are you hearing me?
Yeah, we hear you.
Do you have a question?
No.
Okay. Right, and so generalizing starts when you sense an underlying pattern, even if you cannot articulate it. So in your head, you have a sense of where you're going, and you kind of see something happening right across the different patterns or the different bits and pieces of work that you've been doing. Now, if you make a generalization, you have to kind of justify what's going on and so on. And we'll get down to some others eventually. The process of justifying involves more than generalization, with a shift in emphasis from guessing what may be true to seeing why it may be true. So you have to justify your answer, give good reasons why that makes your answer good and strong and sound. Refuting. To refute a generalization is simply to produce a counterexample or to show that that generalization really does not work. Or if it is a generalization, it only works for odd numbers or it only works for even numbers and so on. So it really is not general for odd and even, maybe just one. Did I promise you a break?
Yes.
Okay. So I'll give you the break as soon as we come to the end of this section. Is that okay?
Yeah.
Yes.
Right, because we're off to a late start, so I figure. Now, convincing, which is the last one that we spoke about, is a process of giving reasons in order to show others that a solution is true. So here's what convincing is. You're not just convincing yourself, but you're going out there and you're standing in front of the mathematicians and you're saying, without a doubt, it works. So the idea of proofs is also tied to helping to convince other persons. Now, as you read, you will find out that publishing doesn't happen if you don't have proof. So you could do the best piece of mathematical work. If you don't provide proof, some kind of proofs, and we'll talk about proofs in one of our classes next week, your paper will not get published. You will not be recognized as a mathematician if you are not able to prove whatever you come up with. All right, even if it's good work. Now, explaining, I think we can figure out that one, where students describe their thoughts and ideas and, so on, whatever they're reasoning about. Okay. From that, we talk about two different kinds of learning or two different kinds of reasoning: inductive reasoning and deductive reasoning, or deductive learning and deductive learning. Now, inductive learning is where we start out looking at special cases, we make some conjecture, and then from those special cases, we're able to generalize. Well, on the reverse, we could get a generalization and we have to kind of go back to see if it really works. And so we're using some deductive reasoning from the general case to go back and check through specializing to see if the generalization holds up. Okay? I think we can take a small break. Okay? When we come back, we will talk about, can mathematical thinking be taught? What conditions are necessary to foster it? And Orinthos? That's your name?
Yep.
Did I say it correctly? I hope you'll wake up by that time.
Yeah.
Yes.
I'm up. I'm always up.
Alright? Okay, so for those of you who didn't get a chance to read the article, this is probably a time when, if you're not using the break otherwise, you could scan through the article to see if there's anything you can contribute when we resume. Alright? The link is in your email if you didn't already download it. The habits of mind. Yes. And you set it up. You didn't set it, did you? No?
No.
Okay, could you start? You pull it over. Alright. So you could take your 15 minutes break and then come back. What time is it now?
10:30.
10:30. We resume at 10:45.
You check it up? I was
I'm looking.
Oh, okay. Good day, everyone. Adrian,
Yes, miss, here.
Bermuda.
Live here.
Okay, welcome back. I just wanted to quickly find out a little about those persons who came in after we started and did the introductions. I'm Camay Hunter, as you by now know. Just wanted you to tell me a little about yourself. Are you working as a teacher? Do you have teaching experience?
Would you like me to start?
Yes, sure. Thanks.
My name is Crystal. I'm not currently working as a teacher. I didn't have any teacher experience, but I do have a passion to teach. So hence the reason why I'm in this class.
It's what kind of class?
I said I do have a passion to teach. That's why I decided to take on this. Yeah.
Okay.
And I just had a big one baby, so hence the reason why some days I'm going to be late. I've had a baby through this class, so I apologize about my card.
Congratulations. I know how it is when you have a young baby. It's very demanding.
Yeah.
Yes, and so what I'm going to suggest is that as much as you can get done while you're away from the baby. Yes, because when you are with the baby, it's difficult. But congratulations. Is it a boy or a girl?
He's a boy, Christian.
Okay.
Yeah.
Years from now, I expect to meet him. Who else did I not speak to this morning?
Can you do something?
Yeah,
No.
Okay.
It's your turn.
It's Rosina, you said?
If what?
Okay, so my name is Rosina, and I, like Crystal, do not have any teaching experience. And I'm not working in the education department. But I've always worked with young people and been interested in teaching. So, like Crystal also was passionate about and decided to take the course.
Oh, that's interesting and that's nice. I suppose you have some interest in mathematics, though, even if nothing.
Well, it's always been something I wanted to do anyway. But
Okay.
made a decision to go to accounting. So. I also have 3 young boys who are in the 3 levels of school: primary, middle, and intermediate.
Where? Adrian?
Yes, miss.
I'm hearing some sounds. I'm not sure where it is coming from exactly.
Alright,
That's not your end, is it?
no, my microphone is on mute, miss.
Okay. Alright, so, alright, let us try to minimize any kind of disruption because the sound alters the quality. The disruptions alter the quality of the sound. And sometimes I'm not able to hear, like I wasn't able to hear very clearly what you were saying just now. Rosina.
Okay. So
And I
you
hate to
start again.
ask you to repeat, but I would appreciate it. I would.
Okay, so my name is Christina, and I, like Crystal, do not have any teaching experience, and I'm not teaching in the current school system. But I've always worked with young people in my life. So it's always been an interest of mine to teach math or teach, period. But decided to get into accounting because I thought more exciting.
Oh, okay.
And so I have 3 young boys who are in the 3 different systems, middle, senior, and primary.
Okay. Congratulations, you have a lot of work
Yes, I see that.
raising 3 boys. I'm sure you'll find a formula that works.
Yes, we try.
Right. Now, we started talking about mathematical thinking this morning, and I want us to reflect on the activity you did with the time clock. Do you remember that activity?
Yeah. Just a note, Miss Hunter.
I'm listening.
We have a meeting with our coordinator at about 2:30. So we may be out for a minute, and then I hope we'll be back in time for the rest of the class.
Okay, you need how much time?
We're not sure. We're not sure.
Okay.
We are-
Oh, you mean the entire campus there?
Yeah.
Yeah.
Okay, so you may be out for the afternoon session then.
I hope not. Because we're going for lunch at what? 2:00 or 2:50?
In about what was it just now? We have 1 hour and then lunch. So in another 45 minutes we should be going to lunch.
So can we move lunch a little bit?
Can we move it a little bit later?
If we can push lunch at later
Yes.
The start of
from
lunch.
the others, would you need to go to lunch in 45 minutes, or can you give another half an hour?
It's fine.
Well, you just go. Adrian,
I don't mind, miss. I don't mind at all.
You guys are the greatest.
please let me know if you really need to stop. Okay?
Yeah.
Yeah, miss.
Okay. All right then. Thank you. So I wanted to ask you, can it be taught? You know, can we teach students how to think? What do we need to do to foster mathematical thinking if it is possible to teach them how to think? And I would love some responses from that. Donald wants to take a shot. Can we teach people to think?
I would want to say yes.
Okay, can we teach them to think about mathematics in a certain way that goes beyond just the classroom?
Sure, definitely.
Okay. All right. Anybody else? Do you think we can teach mathematical thinking?
Yes, but I think it's, I mean, my view, I'm not saying this is correct, but in my opinion, it's possible, but really could it be taught at a younger age? I think it may have to start with children playing with Lego, because Lego helps you build your concepts of putting things together, and that also builds a lot of mathematical thinking.
Mm-hmm.
I'm not sure.
Okay, so
That's
no, listen, don't worry about being sure of something. Your contributions are very important to this class, and you will find that more and more I will share my ideas, but it doesn't mean that I am correct and it is the only thing that you should think. I want you to think of what your own ideas are and share them. So don't apologize for your own ideas. Now, you feel that we can stimulate thinking from a very early age.
yes.
Interesting and important.
Yes.
So we can provoke those kinds of thinking skills. We may not necessarily be able to teach them how to do it exactly, but we can do things inside the classroom that's going to help to foster thinking. I'll share with you an example, just a scenario from experience. And experience here means reading, classroom teaching, wherever the experiences come from, all right? Or just you made up something. Now, let's say you have some students and you're teaching percentages. Is everybody hearing me clearly?
Yes, miss.
You're teaching percentages, but of course, some students are not quite getting it. For example, if you say there's a 20% discount, then they will take for each item 20% and do a sum of the percentages. So for example, if you give them a scenario and you ask them to discount 2 items at 20%, then what they will do is do 40% across the board as a discount. Now, you're thinking, what's that? Where did that come from? Some time ago, the same teachers they had in math, maybe you, maybe somebody else, told them that 20 plus 20 would make 40. Am I correct?
Yeah.
What
Right.
has changed? Now, you could spend 10 days or different classes explaining why it should be 20% across the board as opposed to 20 plus 20. Let's try a different approach, because I believe our approach is what helps to provoke thinking rather than just explaining using the same means all the time. It's not working, try something else. I walked into a store, and this is what I'm telling my students now. And of course, they had some really nice blouses on sale, and they said these blouses were on 20% discount. Of course, I'm happy. And so I walk in and I pick up one, but there are so many different styles, I had to take up another. I walk up to the cashier and I say to the cashier, well, I like these blouses, could I have them? And she cashes me out and gives me 40% because guess what? There's 20 on one, 20 on the other, and of course there's 40. And I ask my students, what would you do? And I'm asking you now, what would you do?
I'm sorry. So you have to take the individual, you'll have to show them how the 40% is not correct in the sense of.
Let's ask a Jamaican.
Oh, sorry.
Don't worry, nothing wrong with your response. Very good response. Let's get one from the Jamaican. Okay? Orinthus, you want to tell me what you would do? What would you do?
An honest person would probably correct the cash register, but in this sense,
So Rosina is the honest person. The next person
Yes.
would probably do what? What would you do? No, I'm not judging your consciences here. That's not the purpose of it. The focus is on the mathematics. Ah, here we go.
I was gonna get another shirt taking 60%.
You pick up another shirt. Okay, you get 60%.
All sales are final.
All sales are final. Why not pick up 3 more, as Karina says?
I'm making 100%.
Here's the question. When you get to the cashier with 5 blouses, and she rings you up at 100% discount, what do you think is gonna happen in her mind?
something's wrong.
I'm not.
She's gonna realize.
She would have to be, she'd have to realize that something is wrong. Because if you walk out of the store with 5 blouses and not pay for them, who is gonna pay for them?
She will.
Ah.
You know what I'm saying?
Now,
That's why I wouldn't do that.
based on that scenario, do you think it would make better sense to throw the student's mind in a spin like that? Let them
Yes.
experience some kind of cognitive conflict. So you force them to think, what am I not doing right? What is not making sense? How do I fix it? It is reflection on your own actions or reflection on your own ideas or your own doing of the mathematics that's going to help you to deepen your understanding of these things. You don't have to tell a student why you shouldn't add 20 plus 20 plus 25 times. Because if they were the cashier in this store, regardless of their mathematical skills, common sense would now tell you somebody can't walk out of here with 5 blouses and not pay for them.
Right.
Do you see where I'm going?
Yeah.
And
Yes.
so we're suggesting that presenting some kind of cognitive conflict, some kind of experience where students will think about a situation, use the mathematics, but understand that the mathematics can be used in some ways and not in others. All right? So that's just one way. What kind of conditions do we have to create inside the classroom? Remember we spoke earlier about there being the affective side, and if your teacher is not so nice, one of the things or one of the elements that can affect the mathematical part of it. If the teacher is not so nice, then the personality could affect, one, your confidence, how you connect with the mathematics and the person teaching it. Do you agree?
Yep.
What
Yes,
else?
miss.
Okay, so one condition that we're going to agree is that the teacher must be someone that is approachable, and the kinds of questions that the teacher will use should help to provoke thinking about one's thinking. Anything else that we have to ensure that is in place?
Contra.
Yes.
Suppose if they said 40%, and to get them to think, is it correct to say, like, to ask them why did they think 40% as opposed to the 20%? So that you can kind of find out what their logic is, because we're making the assumption that they're added to 20%.
Okay, it is important. It is a very important thing to ask them to explain their thinking. It is very important. And so to say whether it is correct, different persons will take different approaches, and I have no issue with a teacher trying to figure out how did you come to that solution. Now, having figured out how the student got to that solution, how do you move them on from where they are? Assuming that more than likely to get 40 from 20 and 20, they would have had to do some addition of the percentages, right? But it's good to understand where they're coming from, because it's not always going to be as straightforward as that either. You agree?
Yeah.
Right, so it's not always that straightforward. Yes.
Miss, the lady who is going to be my, I guess my mentor or whatever you want to call it, she said that to me that this, while I'm going to be in her class, I'm not to smile at the students because she wants her students to take her serious. So she's going to be very harsh with her students. If that's not what we're being taught in our class, like how am I supposed to learn from that?
Excuse me, are you speaking about your mentor for the practical?
Yes.
Maybe you should come to Jamaica to do your practical.
All right.
Like I just think math is like it's a serious subject in itself. So why would you put emphasis on being a serious teacher? Is that really going to engage the learners? You know what I mean?
And I know what you mean. And I tend to be leaning to getting your students to understand that you are a real person helps them to connect with you better, generally speaking. And you can do some reading. Carl Rogers, I think, speaks about that. If you look at what he speaks about, as a matter of fact, if we were to start describing our own experiences with math, and we started talking about when was it that you enjoyed math the most? If we did that experiment now, I'm not really going to do it, but you would find that probably most of the persons in here would talk about their most enjoyable experiences with math being associated with the personalities of their teachers. Very often we forget that if the emotional environment is not right, it is difficult to learn mathematics. So it's not just the challenge of the content itself, but also the kind of atmosphere that we create inside the classroom. Right? If you walk into a class and you start telling students about higher level mathematics and showing them what to do and so on, very often they do not connect with it. You start out from a place where they are, you use some examples that they would be able to relate to. You find that eventually you begin to introduce concepts that are complex, and it makes it easier for them to connect with it because they find the mathematics a little more friendly when your personality is also warm. Yes, I don't know, but as students, if you can recall, that probably did affect your own experience with math. Okay. We spoke just now about taking care of the affective side, which is what we're actually talking about. Students who have difficulties with math and fear and they don't get very many successes, they tend to withdraw and have a sense of failure and incapacity simply because they're not having enough success. When you feel happy about the subject, when you're having success, definitely you will be more encouraged to do the mathematics. There is also the positive side. When there's that element of surprise, intrigue, curiosity, it pulls the student to want to engage in mathematics, attack it, so to speak. So you're solving a problem, and when you're solving the problem, once it is introduced in a way that makes you interested, then you're going to want to try it. Teacher comes in, places something on your desk and say, do this. For example, probably when you saw the assignment schedule, there's some hostility going on between you and that schedule. Like, are we really going to have to do this? No, I'm hoping that by the end of this week, we will all find a place where we can start. Today's class, I would have shown you an idea of specializing, that you could start with. And when you start specializing, you start looking for some patterns if they exist. Start looking for some kind of rule that stretches across all of these patterns. And eventually you will come up with something. You can talk about it amongst yourselves. It's just that you're going to present the ideas individually. Right? Now, confidence, it says whether thinking engages or subsides is dependent on confidence that students have in their own abilities from the successes they've had, etc. So as teachers, we want to ensure that we start students at a point, if possible, every single class, we try to arrange it so that every student, even those with the lowest ability, can access some of the mathematics. They don't have to have 100% success, but they need to feel that there is some amount or some measure of success that they can achieve, and that will help them to want to try the mathematics that you're asking them to do. All right? Some of the factors influencing the effectiveness of mathematical thinking. Now, competence in using the processes, we spoke about those processes earlier of mathematical inquiry. If students are confident that they can try this and work on this, try some special cases, and they will eventually come up with something, they will be willing to try. And they will engage in mathematical thinking simply because they feel they have access to. When we talk about equitable practices in the mathematics classroom, one of the things we have to ensure is that every single student that sits in front of us can find a way to make a contribution to what we're doing. The confidence in handling all the issues surrounding the mathematics. Notice it speaks of the emotional and the psychological states. Now, and of course, we always focus on understanding the content, because it's important that they understand some content that allows them to solve these problems. The context as well is sometimes important. So if, for example, the problem we're asking students to solve or to think about is inside, say, a physics or engineering or medical kind of area, if there is some understanding of the concept, the context rather, it helps them to deal better with the understanding of content, context, and the understanding is better if they are able to do that. So the area of application is clear to them, then definitely it helps to make their mathematical thinking even better. All right?
Miss.
Yes. Yes,
If
Adrian?
if you had to arrange them in order of importance, which would come first?
Class, you're going to help me out here. Which is most important? The competence in using these processes, confidence in handling the emotional parts of it, or an understanding of the content and context?
I would say confidence for me. Confidence in handling the emotional and psychological state that will come first.
Okay.
The competence in using the processes will be second, and then the confidence and confidence will be last.
So it would be 2, 1, 3.
For me, yes.
Okay, so for you? Okay, so you said 3 would be most important, right? Okay, so you think maybe in reverse order? Or
Understand. But that's how I understand it first. Confidence in handling emotional confidence. But I said 3, 1, 2.
okay, so 3, 1, 2. You wanna vote?
Yeah.
Anybody else would like to take this on?
Oh, something like opposite.
Adrian? Are you hearing? Are you hearing?
Yes.
Okay. What do you think so far?
The reason why I asked the question is that I would give preference to 3. I would put 3 first. I'm not sure about 1 and 2. But definitely I would say 3 first.
Okay. All right, anybody else? Are they gone?
No, we're here.
We're here.
Okay, so Bermuda, anybody would like to contribute to that voting process?
Mine's the same as yours.
I think we all heard the same consensus as Gemma.
You figured they're all equally important?
The confidence is first.
That's what you said?
And the mindset. Yeah, and the confidence.
Yeah. Confidence.
Okay, so you said,
I would say I think confidence first thing.
which one is the first thing?
I would say confidence for me, because I think
Okay,
that we
so-
do like the
Okay,
is that what we're doing? That would be like the introductory activity for building their confidence.
that's number 1, then which one?
Then I think the third one would be 2, and then the last one would be the competence.
So as
I
they are,
guess when I think about it, I thought of it as I'm doing a lesson plan. Like first I want to build up their confidence, and then I want to let them understand the content, and then I want to make sure that they actually know what they're doing with the confidence.
okay. So I'm not going to necessarily take a side, but I'm going to ask this question. And there are different questions I could ask to cause you to probably want to choose a different one than you did. But let's say that to learn any new mathematics, you walk into a classroom and the teacher is going to take responsibility for helping you to understand the content and the context. Now, a video can very often introduce the context, right? The teacher may have requisite knowledge to use your previous knowledge to help you to understand the content you need to solve a problem. Now, if I walk into a classroom as a student and I feel good enough about going into that classroom and wanting to do some math, and whatever the teacher does makes me feel that today is a good day to learn math, I already know how to think, how to handle certain skills, then you can always introduce new content and eventually I will solve the problem. I don't know, you don't have to agree, I'm not saying there is a specific order, I just believe that all three are important, and maybe in some instances, some may be more important than others. So I believe it depends on the circumstance, the situation, and whatever you are doing at the time. All right? But I believe at all times the three are important. I won't put any rank order on both. But feel free. Adrian?
Yes, miss.
Have I sufficiently handled your question?
Yes, miss. You have,
Okay.
yes.
Do you have a personal preference though?
Yes, my personal preference is content, of course.
Okay, so 3 first and then the others fall somewhere after that.
Yes.
Okay. Now, many mathematicians probably do not consider the emotional side, but for the students that we teach, I'm going to ask that we begin to think about how the interaction, the social interaction between ourselves and our students and even our peers can help us to learn. Think about when you're doing teamwork. If the vibe, so to speak, is right, if the chemistry is right, you tend to get more done as a team. Mathematics or otherwise. Would you agree?
Yeah.
Okay, so I want you to think about that. Now, the article that you will be reading or would have read over the weekend, entitled Folding Corners of the Habits of Mind, speaks to habits of mind. And I'm going to, how many of you have heard of habits of mind before this class? Is that a hand in Bermuda?
No.
Okay. All right. I'm going to briefly introduce you to the idea of what Paul Goldenberg and some of his colleagues looked at as the habits of mind. And this is their own words. Paul said in his article, the article is the article is entitled Habits of Mind as an Organizer for the Curriculum. I will send you that article and you'll find some time, I suppose, to read it. And it will help you to better understand this idea of habits of mind. But just very quickly, he said that by habits of mind, we mean ways of thinking that one acquires so well, makes so natural, and incorporates so fully into one's repertoire that they become mental habits. We know what habits are, right?
Mm-hmm.
Yeah.
Something that you do without thinking.
Yeah.
It's kind of like a reflex. Sorry. Do we agree?
Yes.
Yes.
It says not only can one draw upon them easily, one is likely to do so. And I've put in, they're inclined to do so. So you're going to do it simply because it's part of how you operate. So if you come in the mornings and you have a particular way of operating, you're likely to just go ahead and do that. If you're presented with a math problem and you are the kind of person to do some kind of diagramming, to draw or sketch what comes to your mind after you've read a problem, you're going to automatically do that. And so they're saying that habits of mind are these habits that you've picked up as you've worked with mathematics. And it doesn't only relate to mathematics, but for our context, it's math. That you're going to quickly draw on, you're going to be likely to use when you're trying to figure out a problem. Really, the idea is that taking these particular ways of thinking seriously and giving them some top priority will improve thinking skills and your understanding of mathematical concepts. So that's the idea. They're hoping that instead of doing the mathematics and learning these skills, by engaging in these kinds of skills, you will be able to learn any content there is by approaching it in a certain kind of way. Just like we spoke about earlier this morning, the thinking behind what you do, the processes, and not so much the content. In the article that Goldenberg, Al-Kuku, and some others wrote, They spoke about some habits of mind. I've picked out just some. There are there are a number of other habits of mind. And these habits of mind have different focus. The article you'll read will look at invariance and some others. One of the articles. Now, when you are able to look for invariance, we're talking about you are going through and you're seeing so many different things happening in a problem. But your ability to pull some kind of regularity or see some kind of pattern, even though the different things are changing. So if I can draw on the arrangement of tiles, stone wall tiles this morning, even though you would have seen one with 3 by 3, 5 by 5, 7 by 7, we've not yet done 4 by 4 or 6 by 6. But from those, you may be able to see some general kind of idea. Even though the situation is varying, you are seeing some kind of regularity. And so that look for invariance speaks about the ability to see some kind of regularity even amidst the differences. Simply put, all right? Now, to tinker, the inclination to tinker is one of the habits of mind that they speak about. Does anybody know that term, tinker?
Trial and error.
Yes,
again?
to play with. Somebody says to play with. That's one way of putting it, yes? You were saying?
No, I said trial and error. When you say tinker, just trial and error.
Oh, yes, so that's a part of it. Yes, it does involve some trial and error. We'll talk about that just in just a bit, a little more about what it means to tinker in this context. Visualize, interpreting diagrams, the ability to describe formally and also informally what we see, what we think about, what we do as mathematics. The ability to translate visual to verbal and verbal ideas to visual ideas. So when I talk about a triangle, what comes to your mind? Can you draw a triangle? Now if I become more specific and I say I need an isosceles triangle or I need a right triangle, are you able to translate what I just said to something else? It is important that these skills are developed, and mathematics seems to be the context in which these are best developed. Right? It's not my idea. When you read, you will see what they say about that. Now, to build systematic explanations and proofs is one of the very foundations of what makes mathematics the subject it is. All right? We're not going to go into proofs, but we will look at it and talk about its importance in determining what mathematics looks like and the nature of mathematics. You remember the name of this, the title of the course or the focus of the course is investigating the nature of mathematics. So we're looking at what is mathematics, how do people operate when they say they're doing mathematics, what are some of the skills that you need to have to be able to be successful at math and so on. And they speak again of the ability to mix experiment with deduction, to kind of do some work back and forth to make sure that what you're thinking and doing does make sense and will stand up in the mathematics court of proofs, I suppose. Now, just two of these I want to focus on. You will, when you read the article, you will be able to talk about the others. The inclination to visualize. You have to be able to, or you need to be able to take explicit and implicit contexts, mathematical contexts, create, manipulate, and read mental images. So whether it is in a classroom context or an outside context, can you see the mathematics inside something that is not explicitly math? Can you mathematize a situation that is not set in a math context? Can you create some kind of mental picture? Can you work and manipulate, change things, you know, do some trial and error, as you say, experiment with, and so on? Can you make sense of visually represented information? Now, the inclination to tinker as we have our students work on experiments all the time, which many mathematics teachers do not do, they just, very often in traditional classroom settings, students are asked to follow this if you get 2 angles on the side, or follow this if you get something else. And so teachers prescribe what is to be done. When students develop these habits of mind, you will not need to prescribe a solution path or a solution strategy. They will, of course, be able to engineer their own. Now, the inclination to tinker is to manipulate in an experimental way. So you're not exactly sure what's going to happen, but let's say you were doing a problem and it was posed and it included ideas about integers or whole numbers or something. Having done it and found some kind of solution, you gotta ask, would it work the same for fractions? And then you try. So you experiment with fractions, you experiment with positives, negatives, odds, evens, and you figure out a way of coming to some kind of generalization, or even testing the generalization that you made about whole numbers. Does it hold for even numbers, odd numbers, fractions? All right? What if we use decimals instead of common fractions? Would it still work? And so on. Now, the idea was to discuss this article, but I suppose I'll have to give you some time to read it. Right. I wouldn't want to tell you too much about it. I don't know. Did you see the article? Alright, so can you grab a sheet of paper? A rectangular sheet maybe? I'm asking each person to get a sheet of paper. If you have blank paper, fine. If not, let me get you some paper. Could I have 4 blank sheets, please?
Thank you now.
Okay, so if you have blank sheets, could we focus on the desk, please?
Like that.
Could we focus the monitor on this?
Rồi, sau này vừa chụp vào đầu tôi là rồi
Could we focus on the desk? Desk.
Can we look at?
Okay, we're now going to use our rectangular sheet of paper and we're going to play around with it a bit. Yes.
Yeah, right here.
Can you see?
Yes.
Can you see? Now, what we have here is a rectangle. In the article, what was used was a square, but of course, as mathematics teachers, you walk into the classroom, you want to improvise, you don't have a square, what do? You make one. You know how to make a square? By paper folding. Do you know how to do that? Simply take the shorter edge of the paper, fold it, let me see, let me make sure, the shorter edge of the paper, fold it along the longer edge. And so we're using the short edge to measure another same length edge, so to speak, from the long side.
Right.
Does that work for you? Now, we already know that the corners are right angles. Can you see? These are right angles. And we're folding, making a diagonal. And then we're gonna fold the top of it away.
Right.
Everybody with me?
Yeah.
Good. Do you now have a square?
Do you
now have a square?
Yes.
Are you convinced it is a square?
Yes.
Okay, alright. So we'll work with our square. If you have cutting tools, you can always cut away that extra portion, or you can fold it neatly, crease along the edge and tear. Not hearing anything from Adrian?
Oh, yes, miss, I'm here.
You made your square already?
Yes, miss, just cutting my edge.
Okay.
Nice stuff.
Students can make a square. Could you permit me to sit for the demonstration? Please? Just so you can see what is happening. Now, in the article, it may help if we label the corners A, B, C, and D, just so that we can refer to them. All right, let's put A at the top left hand and go in a clockwise direction. Just to ensure that everybody is referring to the same letter. So A goes to the top left hand section, and we go in a clockwise direction to put on the labels of the others. Now, in the article, what the experiment is that students are going to be working with the corner C, and they're going to be folding that edge up. Can you see that?
Yeah.
Yes, miss.
And they're just gonna touch that vertex onto some point on the plane. That's our square. If you crease it, what kind of shape do you get? That includes C. So you get a
Triangle.
You get a triangle.
Yeah.
Okay, what if you were to choose a different point to place C? Would you be able to get other shapes?
There you get a triangle.
I want you to experiment.
So you get a rectangle, you do it the other way.
Ah, so you got a rectangle?
Yes. So the right where your fingers are on the left, on the right hand side.
And
And
then,
take it to B, take it to B.
And let me ask a question. By rectangle, do you mean rectangle or do you mean a quadrilateral?
Try to be like that. It's a rectangle, if you go from C to D.
Okay, so if you were to move the point from C to D and fold it in half.
Sorry, C to D.
Yeah, split it in half. Yeah, you're right.
Either C to D or C to D.
Okay,
C to
so
D or C
if you were to, okay, so you could get two rectangles like that.
Yep.
Let us focus on not necessarily touching points A to C or D, but somewhere else inside the plane and see what happens.
Always triangle.
Just experiment with different points. You could make a note, like putting a dot to say where it is that you put it. And so you're trying different points.
As a quadrangle, if you do like that, if you put it in the middle and crease by D and put it up in the middle, just about 5 centimeters from me. Yeah, that's right.
Miss, the only other shape would be a trapezium.
Trapezium would include C.
Yes, by
That's
What other shape? We had to fill something else. Okay, where is the triangle?
So maybe if I take my wrong one, and put it under that speaker, I had two bars. Closer to the base, exactly, or away from the end, closer to the beat, is that shape. Quadrilateral, 4 sides.
Moving the discussion a bit, moving somewhere between A and B. If you were closer to A, if you move the vertex C up to A, he's saying you could get something like a triangle.
There.
And if you kind of slide C towards B, am I describing correctly?
Yeah.
So you begin to get more of the quadrilateral
Yeah.
as you slide more around to B. Now you could mark different points on the paper and try to experiment with it. And I want you to actually do that. It's gonna take some time. And see what the observations are. You could discuss it amongst yourselves.
So you're saying if we get closer to A,
Determine, is there a way to determine when it would be that you'd get some triangles as opposed to when it is that you'd get rectangles? Or not rectangles necessarily, but quadrilaterals?
Anytime you're going in the direction directly at A, it seems like it's always a triangle.
So directly
at A and any diagonal going from that. Diagonal from A to C is always a triangle of some
right, so
kind.
you're saying if the vertex C is pointed directly to A, you will get a triangle.
Yes.
Interesting. And everybody agrees with you. I'm seeing the nods. Adrian?
yes, that's true.
If you move to the right or left of A, what happens?
Right.
Yeah, quadrilateral.
It's quadrilateral from A to C, A to B is a quadrilateral, but from A to D, you're getting
Okay, so when you swing C from left to, from A, sorry, to D, you be said? How about if you were? Okay. All right. You said particularly when you pass the midpoint of AB. Okay. Okay. So after you've passed somewhere about halfway between AB, you get a quadrilateral.
Yes.
What happens if you go between A and D?
same thing.
Same thing meaning what? Triangles or quadrilaterals?
Quadrilateral.
It's a quadrilateral, not a rectangle.
Alright, so if it is, you get a quadrilateral.
Yes.
Alright, I want you to try to think about, you mentioned midpoint. We're talking about a movement. What kind of movement is it? Is it a straight line movement? Is it some kind of curve? Circular movement? You kind of get in a curve when you swing C between A and D.
So if you drill,
No, but wait. So you are getting a, do you think you'd be able to use some dots to outline some kind of a curve?
Possibility. Yeah.
John?
yeah, would be new.
Angle to a quadrilateral. That's what we're really trying to figure out.
Like you still have press ends.
One.
It'll go on. So it's like it. Yeah, it'll make a curve.
It starts out as a triangle.
Yeah, but
So
then
what
it
we said to indicate
Yeah.
is that's a triangle. After the midway point.
So she said put the dust in first.
I did. She said they were on the curve, so we should fill it. And I just put dots.
you're supposed to do triangle first again. So, but it will make a curve.
Yes, miss, you get a curve.
Okay. This is really.
Kind of a circular movement. Use a line to represent it.
Yeah, I get a triangle.
There's no thing.
Just under.
Once you get past the midway.
Oh, going towards it, right? Okay.
I'm sorry, just past it. Okay? Yeah, just past it.
So earlier you mentioned, and do not leave that out because I want it to be considered as well. You mentioned that as you approach the corner of another vertex, you would get a folding in half or two rectangles, right? You remember that? Don't throw it out, still consider it as part of your thinking. So if C were to be pushed up to A, you would get triangles.
Triangle.
If C were to be pushed closer to B, actually, is superimposed on B, you would get rectangles, right? But somewhere between those 2 points, what is happening is that it is changing from giving you a triangle to a rectangle. What is responsible for that? That's what we're trying to figure out, or at least where does it change?
I think it depends on how far up season.
No, I mean the vertex. It's just the mapping of the vertex. When you say how far away, you mean like if it's here, or here, or here?
This
Where does it change?
So for example, that.
yeah. But like if it's here, if you pass the midway,
What is the midway?
the midway point between here
Goes together like. Oh, but how do
The discussion over here?
stuff
Let
to
me give you some time and then we share. They're saying you can pass the midway point. Bermuda is finished? Are you ready to share? Let's talk. Let's share what we've seen so far. Do you want to start?
this kind of song.
Start. Basically, I want us to talk about when it is that we get a triangle, when is it that we get quadrilateral. At what point do we notice a change happening? Alright, so Crystal, I'm picking on you. Well, Kezia wishes to start the discussion. She's
Okay,
Yes, Kezia is gonna go.
I just wanted to know what we're supposed to answer. Well, I noticed that when C is on A point, C is on A, and as B,
Probably place it here. Alright, so Kezia is explaining.
but I was just noticing that my C is on A, and as I move along and moving close, and of course C should be on the paper, right? So as I move inside toward B, then I am still getting triangle, but as I move, still getting a triangle. Then now, one part or one, you see a little side forming.
Yes, beginning to change. As she approaches, based on what I'm seeing, go ahead. As she approaches the midpoint of AB, we're beginning to see the formation of the quadrilateral. And so even just gently moving in that direction, by the time we get to about the midpoint AB, it begins to become a little more obvious because there is a very small side on the quadrilateral. Right? Are you seeing that? I see hands by your side. And
Yes.
right. So, okay. So we're kind of noticing that here. All right. And so Donald also wanted to share that. Did anybody else notice anything else? How about if we tried moving C along AC? C along AC.
Oh, just get a bigger triangle and get smaller.
What kind of triangle?
It just no.
Oh, so somebody said something about similar. You mean similar triangle? The angles. Same effect, meaning. To explain what you mean by same effect. Okay, so all the sides are decreasing at the same rate. Some fancy mathematics over here. Alright, so somebody says that they're seeing some similar triangles. Can we describe the triangle with the type of triangle that we're seeing?
Equal and
I didn't realize
This is
that's right.
This is a rectangle. Yeah.
So even if when you do the dawn, it always be like
Even if what?
even when you move it down from AC, it's still equilateral triangle.
the length
Okay, so
stays
you're-
same as you down.
What kind of triangle are you seeing? Okay, which would mean that the diagonal is the same length as AD probably?
Yes.
Alright, let's talk about that just for a little. What we have formed when we fold it in half along the diagonal is a right angle triangle, would you agree?
Yes.
It would therefore mean that there is kind of a longest side called the hypotenuse. Would you agree again?
Yeah.
Okay, therefore then we would not be able to have.
Yeah. That's true.
Okay, so you agree with that, but you would agree that probably the other two sides would be equal, and so we could call it an isosceles.
Yeah.
Right, so let's agree on an isosceles. And so you're saying if we move it along the diagonal AC, then we continue to get an isosceles triangle that is similar to the half of the square.
Right.
Okay, and we know the properties of similar shapes. Alright, so there are different things that we can come up with. When you read the article, you will notice that even without much mathematical knowledge, you could actually try and experiment some things with the problem. Okay? Now, as to determine finally which sections of the paper would we need to place C to get a rectangle, a quadrilateral as opposed to a triangle, we still need to figure out. Somebody says there is some curved circular thing going on. We can experiment with that a bit more. Please read the article, and if you discover anything new, we'll talk about it in next class. Okay? article as well, we spoke earlier about students having different points to access the problem. It is important that the way the problem is set up or introduced, every student has a chance to actually do something, contribute something, have some measure of success. That's important. We want to ensure that we cater to that feeling of confidence doing mathematics, and it encourages them to go even beyond what they currently are doing. Because if you have confidence that you've solved enough problems, something difficult comes up, you're going to say, well, I've done this before. It's not the same, but I will try. And that is important, that you engage and attack. All right?
6 by 6, that's what it means.
Now, we're going to shift our focus a bit. We've tried 2 problems so far. And we want to talk about how much does it require of us to be able to do mathematics. Could you?
Yeah, we can do it over 1, right? You can do that over 4, right? Over 3, right? She did just not. She took it over.
Kinds of information that we handle. There are different things. So even though we may be talking about thinking, go home. Everybody's falling asleep. Now, okay, the cognitive demands in math. Now, there are different levels of cognitive demand. And when you look at mathematics, you will agree that some things that you need to know in mathematics are more difficult or require more cognitive work. It's a heavier cognitive load than others. There are some things that we just need to remember. We call those retention and recall. And Orton in his book, in 2004, spoke about the words, the symbols, some of the numerical facts that we know. We simply recall that 6 and 4 is 10 without any question, right? 60 and 40 is 100. And anything similar to that will give us a similar response. So 600, 400, that's 10 hundreds or 1,000, right? Now, we use algorithms all the time. Some of them don't even make sense to the students, but they do it. So long division, they do it. Later on, when they come to do long division, when they are dividing polynomials, then they start having problems because they didn't quite understand what was happening. And so the idea of factors or place value didn't make any sense earlier. And so now they're struggling with the long division as it moves from numerals to working with letters. Alright? One of the days, maybe in another course, we'll talk about long division and attaching some meaning to place value. Can we teach them place value? When do they get a chance to use it? Hardly. Yes, they use algorithms for multiplying matrices, and you have to remember which row and which column and so on and so forth. And they learn concepts, they look at the idea of similarity, classifying different types of things based on certain features. They look at relations, they look at limits. And problem solving, they use problem solving strategies to tackle non-routine tasks. And of course, as you look, you will recognize that problem solving seems to rank highest in the set that we're seeing right now. Okay, and problem solving, by problem solving we mean non-routine tasks that they get to work on. So not just the regular textbook type problem that they see every day. You've taught them some, they're doing some, somebody else taught them some. And new problem, they've never seen this before, but sometimes, of course, the mathematics is already in place for them to do that. There's a document that I sent you, I believe. If I haven't, I will send it to you. levels of cognitive demand, and we're just going to quickly look at those. The knowledge and comprehension being at the lowest level or requires least cognitive work, going up to synthesis and evaluation, requiring the greatest amount of cognitive work.
So, Peter,
Right? I'm moving the screen to something else. I want you to
okay.
Right.
Just come.
At level 1, you see in this table?
Yeah.
Okay.
Yeah.
So for knowledge and comprehension, you basically expect students to be making some observations, recall something, know the names of, know what symbols mean. So when you're doing sets, there's a whole lot of that is expected, right? But you do not remain there, because by knowing the symbols in sets, if you are not able to use it to solve a problem applied somewhere, then it hardly makes sense to know them, because it's just a bunch of things that will not mean much by themselves until it's used in a context. Now, how do you get them to do this? You ask them to list, name, define, identify, choose, compute, compare, express as a decimal, or so on and so forth, right? So they know, they have knowledge of these things. Right, let me scroll up. Now at level 2, more is expected. There's some amount of analysis and application that students are expected to do. And so they apply learned information to abstract and real-life situations. So you're going to ask them to apply something, complete something, describe, explain how, extend, connect, classify, because if they understand well enough, they should be able to make classifications. Do you have a question?
Or just
Was it? You could go ahead with your question.
no, we don't have a class.
Or you're not able to see it?
No, we can see it, but we're just reflecting on certain things that we have did on a previous class, and it's actually coming to light now.
Is it better? Alright, the thing is, you'll get this table. I think I already sent it to your email. You'll get this table. So let's just move through it quickly, and then you can go back and look at how at the different levels as a teacher you were required to ask different kinds of questions or pose different kinds of problems for them to be able to utilize these cognitive, skills. You're not going to expect them to always just be recalling, because otherwise they will remain at that level and not be able to think at higher levels where they are able to evaluate any situation at all. Now, at level 3, where there's synthesis and evaluation, they're going to be solving more open-ended type problems, sometimes with more than one correct answer. As young as children are, once they're introduced to formal mathematics, you can, in fact, ask them to solve open-ended problems. Instead of asking, for example, a student at the primary level, or at the early childhood level even, to say, find the sum of 3 and 4, or 7 and 5, you could ask a question like, how many different ways can we get the sum 12? Everybody everybody can give a different answer. As a matter of fact, everybody can give multiple answers. And they will have to figure out how to get to that. Simple as it may sound, it's a different kind of question. Let's go now to the secondary level. We tend to often ask students, find the area of a rectangle that is 10 centimeters by 12 centimeters for argument's sake. Could we ask them, how many different rectangles can you make with an area of 18 or 24 or whatever it is? What this would require them to do, they would have to know what a rectangle is. Right? So I could actually say to you, you have some squared paper. Could you draw some rectangles? And I could say whether whole number sides or fractional sides or whatever to give you the area. I'd probably try to work with whole numbers to make it easier for them to navigate through and get a general understanding of what we're asking them to. But the way we ask a question can make the difference in whether students are required to think or whether they just recall information. That's the basic point, right? I'm taking down the screen again. Could somebody give me a check? After 12? All right. This is a function. Can go. Are we able to continue?
Yes.
Yes. You? I expect. Are we able to continue? Okay. Okay, so you're able to continue for another half an hour? We'll see.
Yeah.
Alright, I'm going to introduce this problem and we're going to actually spend some time to work on it. By doing this problem, we will begin to engage in some kind of skills that you would be able to transfer to use in other problems that you will solve. Even your assignment number 1. Alright? I hope by the end of the day, you go home, even if you're tired, and think about what you now need to do for assignment 1. Alright? Now, let's look at the problem. It's called the point-to-point problem. It says 6 tiles are arranged to form patterns. Now, you can take 6 tiles. You can use, alternatively, since you do not have access to the square tiles, the sheets I gave to you. Those sheets, I hope you did print some. If you can work in pairs, that's the sheets, the square grids. Do you have square grids available?
Yes.
Okay, so you could work together as a group and use shading to shade in. Now, the 6 tiles are arranged to form the patterns and they can only be joined at their vertices at right angles to each other. Their sides must be right angles to each other. So, for example, you would not be able to put 2 tiles, you form some others in the meantime. You would not be able to put 2 tiles and close the sides onto each other. It says each of the patterns is surrounded by a rectangular border and that is shown below. That rectangular border forms the rectangle formed has an area and we can determine the area by mentally filling in the square tiles that are missing. Alright? Do we agree? Or we have different ways of figuring out the answer. I shouldn't even be saying how you should. It says examine different patterns formed with 6 tiles. I want you to use some shading on that paper and try to arrange 6 tiles by their vertices to see what you can get. Now, the area that surrounds it, you find the area, and try to determine for these 6 tiles what is the maximum area you could get and what is the minimum area possible using those rules. Now the first arrangement we have, what is the area of that first rectangle? It's a 6 by 2 and so 12, yes, 12 square units, right? How about the next one that we have?
By
20 square units.
So you're getting a 5 by 4, which is 20 square units. Thank you. Now, is it possible to get anything less than 12 or anything more than 20 as the area? Could you try other arrangements using 6 tiles?
Yes.
Possible to zoom in on the desk up front, please? On the desk up front. No.
5 by 4.
Okay.
Alright, so just pull it up so they can see what's happening. Alright, so just so that we can see the patterns on the desk, right? Right, let's push all. Right, but they are like right. That should work. Alright, could you just allow them to see? Alright, can you see those that are formed here?
Yeah.
Alright. Have you been able to do the shadings? I don't see anybody working, so that's. Oh, I see Crystal. You could pull together if you don't mind. Thank you, I really appreciate that. Adrian, you have square paper down there?
Yes, miss.
Okay, good. Do you want square paper?
Right.
Or is it supposed to shade as well? Yeah, eventually you're gonna need it. Because you don't want to always do it. We'll have mine, because I'm not gonna actually do the work.
1, 2, 3, 4, 5, 6. Yeah. 6. Right here. That's 1.
So we're gonna play the smallest area.
Yeah. 15. Right. Yeah. Yeah, 6.
1, 2, 3, 4, 5, 6.
There's a space here.
So what's the area?
It has to be connected by remember? This
This
should be a
is
space.
this is connected to this. It's connected. It's connected to this. Yeah, you did like the noise first.
Oh, I see what you did.
How you get any other ones?
Were you successful in finding an area smaller than 12?
Smaller than 12.
No, it's possible. Do you think it's possible we can find something bigger than 20? Has anyone found an area larger than 20?
Larger than 20.
24. What is this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 36. And try to focus.
Well, I'm saying
It's only than
it's more than cameras, so I was wondering 12.
there's the enlargement 21. Because you got the 36 one.
Yeah.
So that we just do the okay, 36.
Yeah.
While you are working, let me interrupt a bit. Since it's the first time we're working together, I'm going to suggest that we use a table to record our results. Okay? Bermuda? Adrian?
Yes, miss.
Alright, are you seeing the table? Oh no.
Yes.
So
Yes.
Are you seeing it? I've put up a table on the screen, but I suspect you wouldn't be able to see that screen, right?
No, miss, I thought you were talking the desk.
Oh, the desk, okay. Alright, let me describe the table for you. It has 3 columns. And the first column has as the heading number of tiles. The second column has minimum area. And the third column has maximum area. Do you have that? So if you were to just draw a table, the first column will be number of tiles. And in this case, we're working with 6. But on my table, I've included 3, 4, 5, right down to 8, and then n tiles. Bermuda, are you with me?
Yes,
Yeah.
miss.
Right, so if you just quickly sketch that table, you could use it to record your results, because one of the things we want to do is to look at each result for the special cases. So the special case we're working on now is 6. I'm going to ask you to consider, what if you had 5 tiles? What if you had 4 tiles, 3 tiles, or even more? And then what if you had n tiles? What would the maximum area be that you would expect? And is there a way to determine the minimum that you could get?
Yeah. Yeah, too close.
So you're now working on 6. Have you determined a maximum for 6? What's the highest area you've had so far? Alright,
36.
Alright, so both groups are saying 36. Adrian, have you found anything bigger than that?
No, miss.
Okay, I hope I don't pressure you too much, Adrian.
No, miss. That's okay.
Okay, you're alone down there, and sometimes we could forget you if you're not careful, so that's why. Alright, so if you found that, and you figure there's nothing bigger to find, at least for now, could you try using 5 tiles? Could somebody else try using 7 tiles? And so on. And we're looking for, and somebody else is using 3, so Kezia is using 3 tiles. Donald is gonna try 5. Who is taking 7?
It's twice.
We don't know. It's
Yeah.
a good guess, but we don't know for sure.
No, it's a 5.
Okay.
That's all my general assumption.
Okay.
That's good.
By 2 and hence.
Alright, so we're hearing
Sorry.
somebody's gonna take 7 by 7.
7.
Who is
Yeah, sure.
volunteering? Who is volunteering to take 7 by 7? Alright, thank you. Adrian, which number you wanna do? 8?
I want to do, someone is doing 3 already, miss?
Of course, Adrian. Of course.
Okay. I'll do 7, miss.
Somebody else volunteered for 7. You only have 8 left.
Alright, I'll take 8.
I'm sorry, next time I'll give you 3.
Yeah, my grid is very small.
Yeah, you sure about that? Okay, so you're gonna do those. Remember that you're not only looking for a maximum, you're also looking for a minimum. Karenga is proposing that for the minimum you have 2n, and for the maximum he's proposing n squared. Now, do you agree? Does anybody have something different that they think? And I'm actually gonna challenge him on one of these right now.
Which one? Can you
Repeat that, please, Ms. Hunter?
Okay. Karenga. You know Karenga, right? Karenga is proposing. Karenga? Just wave to them. Jomo, I'm sorry. You know, yes, Jomo. Oh, so Jomo is saying, I'm sorry, I know him as Karenga. That's why. Jomo is saying, for the minimum, you have 2n. So whatever number of tiles you have, you arrange that by 2n, and you'll get the minimum. Now, I beg to differ. That's 3 by 2. Right, that's 3 by 2. You don't see why it's not gonna work? Alright, I'm gonna challenge him on the minimum. He's saying the maximum is n squared. And so does anybody want to challenge him on that, or do you agree that it is n squared?
Agreed.
I'm gonna do it. I'm gonna challenge him. I'm hoping, okay, I'm gonna use 5 tiles. Right? And he's gonna arrange the 5 by 2, and he's gonna let me know what the area is. 5, use 5 tiles. Alright, so 5 by 2 would give 10 for the minimum. And I've used 5. I don't know if you can see right here. There's one in the center, and to each corner I've placed one of these. And I have a 3 by 3. Still 5 tiles and 9 square units. So I'm refuting his claim. You remember we spoke about refuting earlier today?
Yeah.
I'm refuting his claim that the minimum is given by 2n. I'm sorry.
Set by 7.
So what all we have? Everything was 750 times.
No, it's in 8 by 8. He is in 60. 7 by 7.
Was it in small?
No, sacrifice.
In 7?
Destroy that idea.
Things like that, we can see that one.
So,
Yeah, I mean,
7 blocks.
You're on your way.
And then we can do
This.
7, right?
27.
Please.
That is it.
Everyone, yeah. That's my
So is it? Put it on.
like how many blocks there? 3, 6.
That's the idea. And if you take this part out,
Let's give you
Five.
another.
5. I think that's why we're having this. Well, we're
So
not-
you said they can't cut one.
No, they can't. It's gotta be a shade and a white, shade and a white. Not
The
really.
end.
They enter at once. Yeah. So it's different.
So that's 1, 2, 3, 4, 5, 6.
Minimum.
7, that's 9. There's a number.
So here's a 30 people. It's like 8, 6.
So that's how we do it. 15.
This is 15.
So that's the size.
It's revamped.
Not really.
We got it. I'm against the tree. I'm against
5 by 4. This is 10.
Huh?
Can go just diagonal. Just have that diagonal.
This one? Take out this one right here.
Take out that last bottom.
These ones here. So these two here.
And the other towards your thumb. Towards your thumb. Go towards your towards D, yes. Take next to your right. Take these two.
So,
These two birds.
1,
Yeah.
2.
Yeah. Take that out. And then put another one on. Add it to, add it to the, no, it's got 8. It's got 8 there. It should be 3. Take it off the top. One of the bottom.
Oh, okay, I see. 7.
Right. And then you take it. And this is 5 by.
All right, ready to talk? We're getting close to the time when we're gonna close off. Have you found anything so far that you would like to share, talk about?
Just how we got the money, we can go to the coach balance, it's clear for me, because there's still 1, 2, 3, 4, 5, and 1, 2, 3, 1, 2, 3, 4.
I think the formula is correct, you know, miss.
Okay, so you think which one of them, both of them?
Both of them, the minimum and the maximum.
Okay. Now, if it is that I present something that says otherwise, would you accept that maybe it is not?
You want to refute it, miss?
Yes, I would like to.
The maximum is right.
Now, if you focus your attention on the table, on the desk rather, can you see my desk? Or the desk where the others here are working?
And yes.
Yes.
And Mona, you will see some green tiles, 5 of them.
Yes.
We would expect 5 by 2 to give us 10, right?
Yep.
Yes.
Now, I have arranged those 5 tiles in a 3 by 3 arrangement. What would that give us?
3 by 3 is not.
And what would that give us in terms of area?
No. It's green. Color.
Green.
So you cut 1, 2, 3, yeah.
Oh, that's
So that's
fine.
9. Yes, but that is 5.
So that may be 2n minus 1, right?
Yeah.
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 It is 2n minus 1. So it means that this minimum is different from the others that you may have seen. Now, I don't think I have to do 2 examples, but I thought I should.
Miss,
And-
I gotta change
go ahead.
my idea.
Okay, before you change, let me just finish.
It was-
Adrian,
Yes, miss.
Bermuda, I'm
Yeah.
going
Yeah.
to throw in even another example that refutes the 2n claim. I want you to look at the red tiles that are next to it. Those
Red
are
tile
8
two.
next to the
Okay,
green
8 1.
tiles.
Okay.
Right. That's 8 tiles, and it forms a 5 by 3 arrangement, which is 15. Am I correct? which is still less than 2n, right? 2n would be 2 times 8.
Yes, yes, yes.
Yes. Now we're getting you to agree with me, Adrian.
Yes,
Finally.
yes.
Alright, so Jomo wants to change what he said earlier.
Alright. For numbers like 5, 8, 11, like
Numbers like 5, 8, 11. Which
And they
group
go
of
by-
numbers is that? Just
what I
check it.
say, the general formula for number like 5, let's say 5, 8, 3. That'll be the general form.
Would be?
Numbers, anytime you have 5 and you just go by 3 each time,
Okay.
those ones would be, so like for 5, it'd be the 2n minus 1.
Okay.
So for 8, you get 50, the minimum would be 8 times 2 minus 1, 5.
Are you hearing Jomo?
Yes.
They have to talk about it a little louder so they can get it.
Alright, what I'm saying is that the minimum area doesn't hold for numbers, like the first one that it doesn't hold for is number 5. Because with 5 we can get an area of 9. Also, when observing the same pattern that we did, I also did it with 8 and got an area of 15. When I did 11, constructed 11, got an area of 21. So I realized that for numbers like 5, 8, 11, and so then I could generalize it to the 14, 17, 20, 23.
Do you have sufficient examples to generalize about that?
Well, when we use 5, 8, and 11,
Okay,
and then we just
so Jomo is saying if you have 3 that work, then that should be enough.
well, we could have constructed because what I also noticed was a pattern of how it sets. Like when I got the 5 there, I then put the 1 on top, to the side. Put the 1 on top, to the side. So I go by 3, 1 on top, to the side, 1 on top, to the side. I realized that every time I go by 3 from 5, 8, 11, that changes from 2 to.
Okay, so Jomo is saying that for the minimum there are 2 possibilities.
Yeah,
If
one
it's
set.
not 5, 8, and 11 and those numbers when you
Well,
add
by
3,
3,
then you
2n.
could use 2n. If it is 5, 8, 11,
Or give that general
Or-
5 plus 3. No, trend, yeah, trend.
be
plus
careful,
five.
what is
Trend plus
n?
five.
What is
Yeah, you
n?
have to go by 3, so trend.
Depends, you have to find n.
And would be the one, but positive.
You have to be careful now
And what-
what n is defined as. Because the other numbers are considered n as well. You understand?
Alright, P,
So-
3 plus
You still have to be careful, whichever letter you use.
P is a one.
Whole number.
Yeah, well,
The whole number would be what? 3n,
3P
3p plus
5.
5. Okay.
Two different.
So
Five.
2, if p is 2, that's 7.
No, P is 2, 8, 11.
11. Oh.
And
Okay.
14.
So alright, Jomo is saying that for whole numbers 3p plus 5,
Yeah, then
its generalization would not hold as 2n but 2n minus 1 for the minimum. You want to write that down, please? And you're going to check and test it, make sure that Jomo is not convincing us again in the wrong direction. You just want to test?
What's the
Seven.
5 by 1, 2, 3, 4 is 20.
13 should be our minimum.
What do you mean 20? What do we mean? 14 minus
14 minus 3. Is that 2?
is that we need to find that? No, because we ain't gonna live that season. How about you put it in a circle, take up into the triangle. I got 1, 2, 3, 4, 5,
Yes, it will work.
6,
Too.
7,
Right.
2, 3, 1, 2, 3, 4, 5, 6, 7.
alright, but
Back to the
Yeah.
Alright, which was?
And 2n minus 1 clear.
You said 2n minus 1?
14 minus 1. So you might as well put
Crystal?
2 into 1. Yes.
You said 2n minus?
2n minus 1. Is that what you said? We're checking for a formula?
No, you said what?
No,
2n minus 1 would give the minimum
minimum.
if
Yeah. If
you have 3p plus 5, where p represents a whole number.
So that numbers like 5, 8, 11, 14,
Right, so
17, 20.
5, starting with 5, you add 3 each time for the number of tiles. So you'd have 5, then 8, then 11, then 14, and so on. Jomo is saying that the formula for the minimum for those would be 2n minus 1. Is that clear?
Yeah.
Yeah.
Right, he's saying now that 2n would hold for the other numbers.
I'm checking that, you know, miss.
Of course you should, I expect you to.
3.5, so that's that our number? 3 plus 7. Yes, 3.5.
So P is a clear number. So starting from 4.
Works in 2 examples.
So wait a minute.
Works in 2 examples.
I tried it with 2 numbers, two numbers, and it worked.
Which 2 numbers did you try?
I tried 9.
Mm-hmm.
I tried 11 for the 2n minus 1,
Right.
and then I tried 12 for 2n.
Okay, and so which number did you try 9 for?
9.
Which formula, sorry?
Oh, 9 would be 2n.
Yeah. You remember we spoke about looking for regularity where there is variance?
Mm-hmm.
So to come up with some other generalization that takes in both of these sub-generalizations.
One column, everything.
Yeah. That's a challenge. I'm actually going to move on. I have a few other slides, but I will send it to you. There is a problem on it, diagonals of a rectangle, and traversability. I did send you the 2 maps with the networks. You remember those pictures with the planet-looking shapes, spheres?
Yes.
Yes.
Right. Now, I want you to, in your own sweet time before Wednesday, try to figure out which of the 2 networks are traversable. Now, what is traversability? As you will see on the side of the map, it says a network is traversable if you can travel over all its paths once without lifting your tracing implement. So whether your finger or your pencil, without lifting it and without repeating a journey or returning on a journey, it is traversable. So can you go through that maze, going through all of the paths without lifting your pencil or your finger and go over all of them, every single one? That's how we determine if it's traversable. And we'll talk about that next class. Thanks for joining us. Enjoy your lunch, and I'll see you on Wednesday. That's if you have no further questions. Pretty much. We only have like 1.5.
Well, I think one an hour.
Do you have a question, by the way?
No. For R1, that formula wouldn't work. The 2n minus 1, because we have 7, and 7 would not work.
For 7,
Correct?
they're
Yeah.
saying that 7 would actually be 2n and not 2n minus 1.
Right. Right.
2n minus 1 should work for 5, 8, 11,
8.
14, 17, 20, and you continue adding 3 times.
Okay. I just-
Now, what we want
That
to
makes
check,
sense.
we want to check if it does make sense and if it holds for every 3p plus 5, right? Where p is a whole number.
5, 8, 11.
Do you have any questions?
Percent on 1 31, 2. It will be 4. It will be 2n. So 7. The minimum we can do for 7 is 14. Right. So once you start from 5, it'll be 5.
And you can still find me 5 times.
Yeah,
Right.
5 times.
Not
Right.
different.
Right.
Okay.
Can I get everybody's attention just for 1 minute? Let me just ask you very quickly, do you think what we're doing here is mathematics, first of all?
Yes.
Yes, miss.
Sorry for asking fill in the blank questions, the yes and no questions. Not good questions, but I'm still asking. Do you see this kind of activity usually in your classroom?
I see it in primary school.
No.
Feel rushed to finish this problem?
You're right.
Do you feel that
No.
I'm rushing you through completing these problems?
No. No.
All right, now the forum we're working in doesn't allow us sufficient time, but I do not want it to be an excuse for not allowing you to do enough work. It means that as a group, you'll have to meet and try to put some more work in, write about what it is that you are observing, and so on, because it will help you as you work with your own students to slow down the pace of your class and to get your students to think in a different kind of way. And I'm hoping that as we continue doing this kind of activity, you'll realize that I do not necessarily want final solutions every day, but what I want to get you doing is engaged in this kind of work and that you'll feel comfortable doing these problems on your own. Okay?
Okay, miss.
Yes.
Right. If you feel lost or afraid, feel free to call me later or email me and we'll talk about what we can do. Okay?
Yes.
My phone number is 876, that's the area code, 437 5470. Have you done work like this since you started this program?
Yeah, with this.
Yes. Yeah.
Okay. If we start doing a problem and you have done it before, feel free to let me know. Okay? Okay.
More simple.
Yeah, not right.
Oh, to teach.
Not
Okay.
pattern.
Okay.
Other manipulative.
Teaching concepts and so on.
Yeah.
Okay, so using manipulatives.
What is the idea for like saying, that like,
It's the second one.
like, talk about linear.
Okay, using the algebra tabs. Okay. All right, so if you have no further questions,
That's what they are confused. That seems to be too simple.
what is too simple?
No, what we're talking about is, we're talking about one of the questions on here.
Oh, you mean the assignment now seems so simple that
No,
I could change it. I could change it.
no.
Okay, go ahead. All right, so please look at the assignment. I'm not sure you were here this morning when we discussed it.
Yeah.
This one, okay, all right. Having done today's class and Wednesday's class, which can start it today. You'll be able to complete it by Friday. No, I don't know about your workload. I'm ignoring your work. Right? Okay, I should email you now. I'm going to email you right now, so you can have the articles. Well, the article Habits of Mind, I'm going to email that to you as well. I'm sure you'll find it interesting to read. And I put some further readings for you to do. Please try to read even one before next class. Okay?
Okay, miss.
Ladies and gentlemen, you're still hearing me? I'll email you from home.
The number tiles is the number of block.
Not just black, but white as well. So yeah, just have black plus white. And that would be the, so for 7, inside here, you see these empty looking spaces? They're white tiles,
So
yes.
it's a 1, 2, 3, 4, 5, 7, 8, 9, 12, 14, 16, 21, 25, that was 7, like that. And so the different books and so on.
Right.
Okay.
Since you're still here, Adrian? Bermuda
Yes,
left
miss.
us? Bermuda left us? I suppose, because they had something to do. Jomo was just looking at the assignment. Do you have a copy of the schedule in front of you?
Yes, miss, I have them right there.
Right, he wanted to know about how to determine the number of tiles. When you look at the diagram with the town hall tiles, there are some that are shaded and those would be considered the black tiles. Inside of those, there are some that look like empty spaces. Those would be the white tiles. So they're not really empty spaces, they're white tiles.
Okay.
And so for that 7 by 7 arrangement, can you just figure out how many tiles are there so that when you have to do the assignment on your own, you wouldn't have any issue? Just figure out and tell me. All right? You're going to go across the house of the drink and over right to this one. This one.
So, miss, there are 33 white tiles.
All right. The ones on the outside that would complete the square, those are not to be counted. It's just the inside. I figured. That's why I asked. So it's just the ones on the inside that look like blank spaces. The ones on the corners on the outside, don't count those. All right?
Okay, miss.
All right then. Counted?
Yes.
What did you get this time?
Got 9 white tiles.
Okay. And how many black?
16 black tiles.
Okay, very good. And so the total number of tiles would be?
9 plus 16, 25.
Okay. There you go.
Okay, Miss, thanks.
And that's a good start, believe you me. An excellent one. All I have.
So that it was one farm for everything. What's this? And Joe, may I believe you? I don't believe you. Last week, come again? Yours? You're the assignment. Where's your yours? The manager stress. And I go intend to make assignments after the interview. You need to enjoy at least one week. Content map something. That's your one content map in your. For the 60% assignment, there's a part. But a kind of problem with the same 60. So much right to this. Teach student in the meetings. But what's so good? Convinced? Convinced? I'm not sure what it is.
Oh no, we're just trying to find some general topics.
Okay.
Find motivation, see something new, see something new.
How many different special cases for this one?
For example, current, it is about not much exactly of teaching.
Alright.
That's what.
One to be able to make that. Don't go below 5. And sometimes when you do 5, you don't see what you're looking for. So
Okay, that's it.
okay. Don't go below 5. Because the same way that we said 2 p.m. this morning. We could have stopped at that after.
So for both town hall class, that means five different keys. And generalize. Yeah, well,
Oh, you drive? Take care, Adrian.
Alright, thanks, miss. Enjoy the class.
I'm glad you did. I did too. I just wish we didn't have any glitches, but I guess those will be sorted out eventually. Does anybody know this book? This way. Problem solving.
Sure.
That's like that. You can check it. Bookshelf.
Oh no, I haven't had that. So I wonder.
Be curious. You guys like this? Make me don't say it. No, make me there try to kick off.
you.